Very good morning to everyone. Thanks to all the attendees who have joined in for this ninth open policy meeting of IRIN. As you are aware that being the NIR, which Nixie was interested in the year 2012, the conduct of open policy meeting to discuss out the various policy related issues uh, and to just communicate with all the affiliate members. This open policy meeting is being conducted on a yearly basis. Uh, we have been conducting it in a kind of a physical mode also, but since the pandemic, this hybrid mode has become a kind of a recent trend. And the current one is also, the 9th OPM is also being conducted in a virtual mode. Along with this open policy meeting, we have we are also conducting a IPv6 deployment training, wherein the trainers from APNIC, they would be conducting this hands-on training, and this starts at 12 p.m. 12 noon. Again, warm welcome to everyone who has joined us in today's open policy meeting. With this, I would like to introduce our CEO, Dr. Devesh Tyagi, who has been who has been in charge of Nixie since July, and under his vision and leadership, Nixie has been working in the directions of the internet governance and other policy related measures. And I'll request CEO Nixie to give his welcome address to the attendees. Over to you, sir.
This meeting is being recorded.
I welcome all the participants and especially welcome Sri Makitole and George Q, who will be helping us in realizing our vision of IPv6 deployment and policies and procedures related to its implementation. I personally feel that with the advent of internet, the role which IPv4 has played in past, IPv6 is going to play in future. As you see, different technologies, including with the advent of IoT specifically, we are much need of various IP addresses so that all our devices are accommodated on internet, and IPv6 is the solution. I am thankful to all the stakeholders who are working with us in realizing the dream of reaching to everyone on internet through IPv6. You see, IPv4 are scarce in nature at present, and they are almost extinct. But I feel the IPv4, which has given a great impetus to the internet role of internet in our daily life, IPv6 is going to take it forward. What I feel today is that there is a great need of capacity building, which we have to put in place for all our internet users. IPv4 deployment has helped us. We had analyzed and we had find out the ways and means to use it. We are very comfortable with IPv4 addressing and its usage. Same thing has to take it forward for IPv6 as well. I am proud that my organization, Nixie, along with other stakeholders, is working tirelessly for that. At present, you see, there are many number of IPv4 addresses like that, around 13 point some million, and IPv4 has already been deployed through NIXI, and around 11.5 billion of IPv6 has also been allocated to the different stakeholders. What I see is still the usage of IPv4 is very much larger than IPv6. Though our Department of Telecommunication a few years back has come out with a policy that now onwards, it was around 2-3 years back, that all the stakeholders, all the websites will now be dual stack. But I feel despite that policy, we have to take other measures as well to put that thing in place. I feel that session which we are going to conduct today will give impetus in this direction. All of us feel the importance of IPv6 and the security and the speed, because you see IPv6 deployment will be much faster than IPv4 deployment, which we will be able to achieve this through this. Another thing which I want to say today is that we will be conducting APNICIRINN open policy meeting just after around 11, I think it is going to start. And various stakeholders will be giving their views and ideas how to take it forward. Open policy, I feel it is a great thing, and we at NIXI always abide and support this open policy. We had adopted this policy for IPv4 allocation and IPv6 allocation in very transparent manner. And we try to satisfy all our stakeholders by examining their needs and allocating them with IPv4 and IPv6 addresses. I am sure that deliberations and the training session that will be conducted thereafter will help us in realizing our dreams. I thank everybody who has joined us today in our open policy meeting, as well as who will be joining in our training program for IPv6 deployment, and seek their support in realizing our dreams. Thank you very much.
Thank you, sir. Thanks for your opening remarks and setting the tone for today's OPM and the training program. So with this, I would like to hand it over to Mr. Abhishek Mishra and Mr. Chandra Prakash. They'll be taking us through with the current updates and the policy updates. Over to you, Abhishek.
Thank you, sir. As you all know that we have been conducting these open policy meetings for the past 12 years now. This is the 9th open policy meeting. We could not conduct for 2 years because of COVID. So a very warm welcome to everyone. And now I would like to start this meeting with an update about the APNICIRINN, where we are, the current numbers, and what are the policies which are currently in APNIC, which are approved and which are not approved. So I will be sharing you an update on all those also. Yeah, so starting with, as you all are aware that what are the activities which we do, like the allocation of IPv4 address, which is a 32-bit address, IPv6, which is 128-bit, and AS numbers. Apart from these three allocations, we basically we also do the training part, the knowledge upgradation of our affiliates. So these are the few basically operations which we do. Next one is that what are the policy which are in line as on date on which we works. So the policy, as you all know, it should be in line with ethnic policies. So because as per the hierarchy, the IPs, these are coming from the INRs to the 5 RIRs and then to the NIRs. So we have to be on the same page in terms of the allocation policies. So the minimum size as of now for IPv4 is restricted to a /24, which is 256 IPs. There has been a proposal to reduce this maximum size to /24, which I will be covering in my next slides. And the maximum delegation as of now is a /23. So from the 103 pool, which has been already depleted, so there is a small pool which is left with APNIC, from which they are delegating, which the IPs which are returned back to APNIC. So APNIC is further delegating from that pool. So 103 pool is completely exhausted in our RIR also. So as you for IPv6, there is no restrictions as of now. They can, and ISPs can get a /32, and then affiliate can get a /48 for their own infra. Moving on, this is the process which we have been the IRIN portal which we have been updating for the past few years. So our IT team is continuously working on it. So everything is online now. So we are not accepting any hard copies as on date. So first it is to anyone who want to apply for new IP resources, they need to come to our websites irin.in, and then they need to upload the documents, the basic documents, the ARIN affiliation agreement, the identity proof, the MCA documents, and all those details. And along with this, the justification for resources, that why they need this IP resources. This is very important as of now, because the IPv4 has been depleted and a very small chunk of IPv4 is left. So justification part is very, very important. Then the next process, as a third level after verification, we will put up for approval, and once it is approved, the billing team will raise you the invoice. And once you pay the invoice, the IP resources, whatever is required, they will be allocated to you. So this is the current growth in the past 6 years, which we have. Like you can see, there is a substantial growth in the number of affiliates from 2017-18. As on date, we have 4,356 affiliate who has been connected with us. So this is the current growth which we have as on date. Then the terms of IPv4 and IPv6. We have allocated 13.38 IPv6 addresses and 13.42 billion of IPv6 and 11.25 IPv4 as on date. So the IPv6 has been growing because there are more number of IP addresses in IPv6. And as you know that as per the current policy, the IPv6 for IPv4 there is only a restriction for a maximum of 500 IPs. So this is the current growth for IPv4 and IPv6, and because of the various initiatives which we have been taken from the past few years to encourage affiliates to adopt IPv6, we have taken few initiatives like Nixie Academy, IP Guru. We have an IPv6 index portal also. So I think my colleague will explain you more in these initiatives which we have taken. So as on date, we are number one in the adoption of IPv6 as per the reports of APNIC Labs. Moving forward, as on date, we have 80.61 the adoption of IPv6 in our country. And the most, as you all know, that the top 5 here are been for the so many years. It has been Reliance, Bharti, Vodafone, and Idea. But now, as you go down, you can see that Atria has been also gained a bit geared up. It has been moved to 28.52, and I can see Kerala Vision Broadband also from they have also moved to almost 10%. So these players are also coming up with the adoption of IPv6, and that will help to the overall growth of IPv6 within our country. So I think it is a good sign for us. So this is another thing which we have been focusing, and we have been working for so hard for I think 3 to 4 years. I think which I remember from in the mid of 2020, we have started this initiative to get your IP prefix safe from hijacking, from routes hijacking. So get your ROA done. And this is the process for getting your ROA done. You just have to drop us a mail, and with your AS number, the IP prefix, and the MSA, the most specific announcement which you want for IP prefix. We recommend you to get take the maximum, the minimum one, which is /24. It will enable you to do all the prefixes. It will be safe using this ROA one. So, and if you want to check it, whether your ROA is not done or whether it is not fully done, or so there is a link which we will be sharing with you on chat also. So this is the RPKI validator. There you can put up your IP address and your AS numbers, and it will show you the current status, whether your ROA is done or not. So if you have not done it, please do it. But we have got a significant growth in the number of affiliates who have been ROA capable is from 12% in 2020 to 59% as of now. This has been a substantial growth in the past 3 years. And because of our efforts, it's not efforts from one side, effort should be from other side also. So you also have done from your bit whatever you can do. So I think we are thankful to you also, and this number is because of your efforts also. So current for, if we take both IPv4 and IPv6, it is 58.74%, and for IPv6 it is around 52%, and IPv4 as expected it is around 65 to 66%. So average we can say that for India it is 58.74 as of date. Moving further, I think in 21 we have upgraded our fee structure, because since inception of IRIN we have not increased the fees. It was 25,000 only, but in 2021 we have increased 10%. So as on date, the affiliation fees for new affiliate is 27,500 plus taxes, and for IPv4 it is 27,500, and for IPv6 we charge 37,125, which is 10% increase from whatever we are charging before 21. So for IPv6 same, it is for 24,199 for /44 block, which is minimum which we give, and for a /32 for ISPs and other affiliates we charge 44,103. And one more thing which we do, that we calculate the fee for IPv4 and IPv6 separately, and we charge only the higher amount. So, for example, if you go for a /23 of IPv4 and a /48 of IPv6, so we will charge you 37,125, because it is the fees of IPv4 /23, and for /48 IPv6 we will not charge you. So we will charge the higher amount. So like this, if you go for a small block of IPv4, if you have not taken yet, so please, I request you to please go for it, because it will not charge you anything, and you can try with your in your small infra, and just take a move on with it. Yeah. So then, like I was talking earlier, that we have in year 2021, we have started new initiatives, like, because it's not our responsibility to only give IPv4 and IPv6 address. It's our responsibility to educate our affiliates also regarding the new technologies which are coming up. So we have started these new initiatives. So I request my colleague Chand Prakash to please explain us more about these initiatives.
Good morning.
Thank you all for joining this training today, and I don't know, as you know that IPv4 is very less, and IPv6 has the potential to fulfill the requirement for large population in India. IPv6 is like huge address space. Just go ahead and get as you many as you require. Currently, IPv6 adoption is around 80% in India, but IPv6 traffic is still very low. So this is the time to trigger it and move in IPv6. Since IPv4 addresses are almost exhausted, IRIN is encouraging its affiliate to make their network dual stack and move to IPv6 technology. That's the reason NIXI is organizing this training for you with the help of APNIC. We started some initiative in 2021, like NIXI Academy, IPv6 Index, and IPv6 Expert, which is also known as a IP Guru. NIXI Academy is created to educate technical, non-technical people in India to learn and relearn technology like IPv6. This is the easy to use platforms, helps to network operators and educate, understand networking, best practice, principle and techniques. Second one is NIXI IP Index, which is NIXI has developed as IPv6 index portal for the internet community. NIXI IP Index portal will showcase the IPv6 adoption rate in India and across the world. Third one is IP Guru, which is IP Guru is a group to extend support to all the Indian entities who are finding it technically challenging to migrate to and adopt IPv6. In the current year, NIXI conducted several training in virtual as well as physical mode. Like as you can see here, in 2023, we organized many training like DNS, DNSSEC, BGP routing, cyber security, DNS basic, and different DNS threads components. We also organize on physical mode some training in universities and make awareness about cyber security and role of IP resources under the cyber security. So in person, we organize this training about IPv6. What's the role of IPv4, IPv6 role in cyber security, VAPT, and all this type of awareness. We we conduct in different universities and colleges, academia. Next. So now over to Abhishek.
You are saying that there are no voice. Just check. Are we audible?
Yes.
Yes. Are we audible to you? Someone was saying that.
Yes.
Okay. Thank you. Thank you. Thank you. Yeah. So next is the policy proposals. So questions we will take after this the presentations. So just whatever you query, just please put up in the chat, and we will take up once this presentation is over. Yeah. Thank you. So.
Yes,
So the policy proposals which we have, I think you all must be receiving emails from us from the month of July and August from info@irin.in regarding the various proposals which are being put up at APNIC for the Asia Pacific. For your comments, if you want to share your comments, your inputs. So we have been sending updates and mails to you. And so this is the update. I would like to share the updates that what are the proposals that have been either approved or not approved, or it has been sent back to. Yeah. So coming up with the first proposals that that reach consensus at APNIC is to for the associate members of APNIC. Like you all must be knowing that APNIC has 7 type of members. The first one, the basic one, which is the associate one, who don't have IPv4 or IPv6 address. So this proposal says that they can also apply for a small /48 IPv6 address. They can also request with a minimum justification criteria as per the APNIC guidelines, which has been for the IPv6 assignment. So, and it is not mandatory that they have IPv4 also. So this proposal is about that. And the assignments will be evaluated based on the applicant, whatever the need they have, and they will APNIC team will analyze, and as the NIR also we will analyze as per the need, and then the small pool of /48 will be allocated to them. So there is also it is non transferable. As you know that IPv6 is non-transferable. Only in the case of merger and acquisition it can be transferred. So this policy will be applicable for this also, for this assignment also. And as I said, that it's reached consensus at APNIC 56, and now it is for the APNIC EC review, and once it is reviewed, then it will be implemented. Next one is I think most of you won't like this proposal because it will reduce the size of IPv4 delegation from a /23 to a /24. So this proposal suggests the limiting to the maximum delegation as of now, which is 23, to a /24. So including for the APNIC members as well as the NIR members. So this proposal says that all those who have a /23 in their account, they are not eligible for more IPv4 resources once the current space is depleted. So this proposal also suggests that a waiting list should be created once this IPv4 is completely depleted, and it should work on a first come first serve basis. As of now, this proposal did not reach consensus at APNIC 56, and as you all, if some of you must be there with the policy SIG mailing list, and you can see that there are discussions going on in that policy SIG mailing list in this regard. Next proposal is the two changes in the policy development process. There is a step 1 policy development for the changes which request for the call for proposals, the deadline, the submitting of the proposals, and once the proposal is not, it should be returned back to the author for further discussion. So the point was made here is that the language could be improved so that all those the policy proposals who are non-native English speakers in the community can better understand it. And the second, with what was there in the proposal, that it will be ideal if we open the call for proposal once the OPM is over at APNIC conference, because as you all know that APNIC conference, the OPM at APNIC conference goes for 2 to 3 days, and if in between someone call for a proposal, then it might be difficult for people to understand or go for it, or so it will be ideal if we open for call for proposal at the end of the conference final day. So this was the suggestion in these proposals, and however, if it is acceptable to the authors and the community, the APNIC Secretariat can improve the language for the non-native English speakers also. So, but the conclusion is, as on date, is now that it did not reach consensus, and it is again it is back to the policy SIG mailing list for further updates and discussions. The third proposal is proposal is the resizing of IPv4 address for the internet exchange providers. So this proposal suggests that the IPv4 assignment, which is from /23 to a 26 for the IXPs. So and further, for the IXPs can request for more based on the numbers of peers they have, because once the peers is increased, so there is a more need for IPv4 address, so they can further request once the number of peers got increased. So there are more clarifications is required for this proposals, for the current existing, if they have already received a /23, so are they eligible? And if they want to start a new IXP, so are they eligible for it or not? The second, the clarity which is not there, that as you all know that the current the minimum transfer of IPv6 IPv4 as on date is a /24. And if we give a /26 to an ISPs, and once the 5 year is over and they don't want to use it, they want to market transfer it. So there is no policy which allow them to market transfer those resources, because the minimum transfer size is a /24. So these are the few clarifications which are required, and it is further sent back to the policy SIG mailing list, and for open to all to submit their comments. Next is the proposal for that leasing of resources is not acceptable. This has been in discussion for long, but nothing in the policy which says that, clearly says that yes, it is not acceptable. But so that's why it has been renamed, this proposal, that it is clarification that leasing of resources is not acceptable. So this proposal suggests the explicitly stating that the policy document for leasing of resources is not permitted in the APNIC region. It is not clear in the existing policy for that it is not acceptable, and it is, if it is not the integral part of the request when they have submit their request for IPv4. Right. So this proposal also, there is more clarification is required. Does this proposal apply to all existing allocations or only to those delegated after the policy is implemented? Someone has taken IPv4 before this policy has implemented. So whether they can lease it or not, or whether only for those who have taken after this policy are only restricted to this policy. So there are a few clarifications which are required. So, and also that it is restricted either to only to ISPs or LIRs, or it is to everyone. So, and what is the process which APNIC follow? How will they analyze that the people are leasing or not? Because they need to regularly check it, and how will they check it? So these are the few clarifications which need to be done. So so the conclusion is, as on date, it did not reach consensus, and it was abandoned at the last APNIC conference, and it was asked the author to submit a new proposal with these the clarification for these points, and further it will be put up to discussion from the community. So these are the 5 proposals, one which is approved, the 3 are sent back to the authors, and this one is being abandoned, and a new proposal will be submitted by the author very soon. So like I told you earlier also, that this is the link where you can just enroll yourself to this policy SIG mailing list. What are the current proposals? You can visit this site and you can see what are the current proposals. And also you can directly put up your comments at the policy SIG mailing list, or you can send us also at info@iring.in, and we will just forward your suggestion to APNIC. And so this is the current process which we follow. We have been following for the past few years. And I also invite you to please go and submit your comments, whatever you want, what type of policy you want. It is you who decide the policy, and just this is for the RIRs and NIRs to just implement it. So thank you everyone, and I think I would like to take a mic is open, stage is open for everyone, and so you can share your queries as well as your comments.
Hello.
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 Yes, you are audible, sir. Please.
This is Rajesh Panwala from SmartLink Solutions Private Limited.
Yes, sir. Welcome.
See, everything good which has happened The only one question which I have is there are several commitments which are being given to automate the process. All the processes which are automated for APNIC members should also be implemented the same way for the IRIN members. When are we planning for that?
Right, sir. So we have initiated the process. Like you can see that starting from the online application and all those documents, it has been already automated. Moving on further for the who is related queries and updates, we are been working with APNIC, and I think IT team is with me, and I think if you would like to share us an update where we are right now. So I will give it to, yeah, sir.
I'm specifically looking for route object creation, ROA
Route
creation,
object creation.
towards
Right,
DNS
sir.
entry.
Right, sir. So we are, the IT team is working on it with APNIC. So I think I'm passing to for an update.
So hi everybody. We are working on that, and we will implement this tool for all, and we will open this very soon to everybody utilize these services as soon as possible. So
Any specific deadline or anything which is missing from APNIC end?
no, nothing is missing from happening, and we are just planning to migrate whole applications because of there is many updates are available in the technical point of view. So that's the reason we are just migrating all these things along with these services too. Already we had implemented ROA and all these things to utilization services we can find out.
So
For
what
analyze purposes.
will be the timeline for that?
We will let you know further.
Sir, if you can be specific, because this has been raised in last policy meeting also.
Definitely, sir. We will announce this timeline as soon as possible.
Next.
Hello,
Hello.
am I audible?
Next question, please.
Can you please explain what is ROA, its benefits and purpose?
Yes, ROA is basically route authorizations. It basically is authorizing that a particular ASN is authorized to announce a IP prefix or not. So it is basically an attestation of that the announcement of an IP prefix with a ROA. So if you create a ROA, it will authenticate that this ASN is authorized to announce this IP prefix, and what are all the other announcements will become illegal. So anyone cannot illegally announce your IP prefix. Next question, please. कुछ क्वेश्चन लिखा हुआ है गौरव ने चैट पे.
Yeah, so first I would like to thanks Nixie, Abhishek ji and everyone for hosting this OPM. So I have few suggestions or the comments.
Yeah, please go ahead.
Yeah, first one is it's really appreciable that you explain all the proposals which were discussed in APNIC here in detail. So my request or my observations was it would be very helpful if these props will be discussed before APNIC meeting, and we can have the voting if or the feedback from the community and can submit it to APNIC like the way other NIRs do. This will help us in presenting the Indian community view at the APNIC level from an IRIN side. So
right. So we have been doing this before the APNIC conference also. We have sending them mails, and we have inviting their inputs, and from the, I think in the month of July, and we have started, I think 1.5 months before this APNIC conference. So yes, and it has been a regular practice, and whatever suggestion they give us, we will just put up to the APNIC, and whether we go to there physically, then we will present it there, and whether if we are not able to go it physically, then we will be sharing this on mail with them.
So this is we have been doing this practice, and yes, we have not organized such OPM before the conference because we wanted to share them and update that what are the current policies which have been implemented as on date. So this only can be done once this conference is done and once the proposals reach consensus or not. So this was our the thought behind this OPM
Sir,
event.
just two
Yeah,
more comments.
yeah. Please go ahead. Please go ahead.
First one is with respect to IPv6. Sir, in the if we talk about LACNIC, which is an RIR for South American region, what they
Right.
are doing is they are allocating IPv6 address to all its member by default based on the membership tier. Like the way in IRIN or APNIC, we can get free IPv6 address based on the IPv4 address pool which we have. So
Right.
if we can think of having this in IRIN, we will be able to allocate this is only a comment to all our members because the fee charge will not going to impact them. So
Right.
this is comment.
No,
And
that is I think well thought point. But only my the thing is without their consensus, we cannot allocate or deallocate any resources to them as per the policy which are under the APNIC. I think APNIC also does the same. Yes, so we cannot allocate or deallocate without their consensus. So this is the point which I feel that because of this we are.
Okay, I got this from from the in this last happening meeting only,
Yeah,
so I was just thinking on this.
maybe they must have been
Yeah.
whatever internal discussion they have as per their geography and how they work their how so they have taken this call for their as per their working. But here I think it is very difficult for us to implement anything of such sort without the consensus of the member whether they want to take it or not. And
Yes, sir.
so I feel it. Yeah, we will. I
Just
just
last one question, sir. With respect to the IPv6 address, which anyone can get /48 as per the new latest proposal, free of
right.
cost. So, sir, in case if an user or organization does not have any membership from IRIN, can I and the user is not paying anything to IRIN, so can we get can that user get a /48 from IRIN without asking or without giving any membership fee to IRIN?
No, that is not possible. You any resources you take, you have to become an IRIN member first, right?
Okay.
The APNIC also they are being associate members for APNIC for long, right? Then only they are eligible for a /48 minimum.
Okay.
So yeah, and I think there is a question regarding of you in the chat. I can see that about the ASN that whether IRIN is charging anything for ASN or not. So yeah, I would want to reply for that we as on date we are not charging anything for the ASN. I know that some of the NIRs they charge, but we at IRIN we don't charge anything for the ASN. It's just that you have to use the ASN from the date of 3 months within the date from allocation.
Okay. Thank you.
Okay, thank you for your comments. Yeah, please.
Aditya Singh.
Hi everyone. Hi, good afternoon. Good afternoon, all members.
Yeah, good afternoon. Please go ahead.
This time we are facing issue with IPv6 subnetting and deployment.
Okay.
Yes, because we have many times tried to deploy, but still
Okay.
we are not getting pings on our servers. Our node servers.
Okay, so I think for you the best thing is we'll be starting after 15 minutes. We have been a training organized from APNIC, which will help you to understand how to do the subnetting and how to implement IPv6 in your network. You please attend that, and you and your team. I would request you who are the network persons of your team. Please attend that quad training, and you can ask them also that how we move ahead. You can tell your scenario to them that what are your infra right now, what are the type of equipments you are using, and how to just subnet and how to use IPv6 in that network. And after this that training also, if you find difficult, and like in our presentation you have seen that we have started few initiatives. So IP expert is one of the initiative, IP guru.
So you just go to our website, just submit your queries to us, and then we will connect any of the IPv6 expert and guru to you, and that it will help you to get your network IPv6.
Thank you so much. So I have one more question.
Yeah, please.
How many pool we raise for the IPv6?
How many pool you can request for IPv6?
Yeah.
Yeah, as of now for IPv6 there is no restriction. You can but you need to implement those IPs. It's not that you can take a big block and you don't use it and then you come to us for more IPv6, right? Once you use a /32, you can come back to us again that we have fully used or we have 80% used this IPv6, and please allocate me one more, then we will give you another pool of /32.
And we have already two pool IPv4, but
Two pool of how much?
two pool of IPv4.
/48 or 32?
/24.
/24 of IPv4.
Yes.
Okay. So
He already reserved all VPS server, but we need two more IPv4. So how to request?
you need to check it whether these IPv4 are from the last /8 or not. If it is from the last /8, then you are not eligible, as per I have explained in my slide also, the IPv4. And so this is what that we are almost exhausted with IPv4. It is our only RIR who are giving a few pool of IPv6. All the other NIRs, they have been already exhausted with IPv4.
Because of this, due to IP resources, due to IP resources, will may losses many customers because we are not any IP for sale our customers.
Yes, I truly understand. But you also understand that for a class A ISP, I think they have for pan India coverage, they can only have a 512 IPv4. So the only solution to is just start with a small pool of IPv4 and then expand your network with IPv6.
Sure. Thank you so much.
Solution which I can give as of now.
Yeah. Okay. Thank you so much. Thanks everyone.
Welcome. Thanks. Next, anyone else? If you have any suggestion or comments. Any question, please? आप क्लोज करेंगे सब 2 मिनट का बस if not, so I request my friend from APNIC, George Ko, to please share your views about the iron opium and your comments on this. So please, George, thank you for joining and please share your.
Abhishek, thank you. It's really my pleasure to be able to join ERIN's OPM. I think it's very important the OPM provide opportunity for the ERIN community to be able to share information and ask questions. And especially, I want to thank you for a very good policy update. As we all know, the policy development process can be participated by everyone who are interested in the subject, who are using and running operation of the internet. Basically, if you're interested, you can participate. And also with APNIC, there's always a lot of information for you from the apnic.net/policies, and that's where we share a lot of policy proposals and discussions. So once again, I'd like to congratulate you for having a very interactive session, allow your affiliates to ask questions and interact with each other. And I've learned from this OPM. Thank you very much.
Thank you, George. Thank you. So now I think I request Shubham sir for any closing remarks so we can
can conclude this meeting.
So, thanks everyone. Thanks Abhishek. Thanks Prakash for taking us through with those updates. And I thank each and every participant who have raised query here because the queries or the questions you might be having can benefit all the other participants because you never know that a similar kind of a query or a challenge might be faced by others as well. So thanks for raising that particular questions here. With this, we would like to conclude this particular session. But the overall session for today will continue, which includes the IPv6 deployment training. And I'm thankful to the APNIC team and to the APNIC trainers who are here to help us and who are here to take us through this entire session. So thanks everyone, and over to you. Like if we can just move it to the training section.
Yeah. So thank you everyone. So as you all know that there is a training on IPv6 within in 5 minutes now. So the same link it's an update for you that the same link will work. You don't have to switch to any other link for the IPv6 training. And just we will have a 5 minutes break. And after that, we will start the training. So thank you. Thank you everyone for joining.
Hi, Makito and Abdul. Am I audible?
Can take over from here.
Hello, can you hear me?
Yeah, Makito. Now over to you.
Okay, thank you. So now we will start our training. Hello again, everyone. Good afternoon, everyone. Welcome to the APNICIRINN IPv6 configuration and implementation training. I am Makito. Together with Awal, today we will be the trainers that deliver this training. First of all, let me introduce myself. I am the network analyst and technical trainer at APNIC. And before joining APNIC, I spent approximately 18 years in the ISP industry, mainly focusing on the routing and switching like OSPF, BGP, service provider technologies. And very happy to meet everyone here. I hope we can have a fruitful training, and along the way, if you have any question, feel free to raise your question in the chat box. Now I will hand over to Awal for his self-introduction.
Thank you, Makito. Welcome, everybody. I'm very happy and very delighted to be here in this training. My name is Abdul Awal. I am one of the trainers at the training delivery team at APNIC. In this today's tutorial training, I would encourage all of you to ask questions whenever you have some question in your mind. Please interrupt us, ask questions. Let's make it more interactive and very fruitful session for you guys. Thank you.
Thank you. So this is the agenda for today's training. There will be 3 sessions starting from 12 o'clock until 4 o'clock. You can see session 1 and 2, they are continuous. So session 1 from 12 to 1, we will talk about introduction and agenda, IPv6 protocol and address, IPv6 subnetting. And then in session 2, we will talk about IPv6 address configuration. In this session 2, we will also include a lab, which is the stateless address auto configuration and DHCP using MicroTech Router OS. Then after that, we will have a 30 minutes break. Then it will be session 3, which we will talk about IPv6 transition techniques and IPv6 security. Here are the resources that we will be used in this training. You can see event page, course materials, and post-event survey and community trainer mailing list. For the event page, maybe after this I will share in the chat box so you can have access directly to the event page, and then you can download all the presentation that we are using today. And after the training, we want to hear from you how we did for this training. So please fill up the survey for us after the training. And for this community trainer mailing list, it is for in case if there are some questions we are unable to answer during the training and you would like to ask, then you can send your technical question to communitytrainers@apnic.net. There will be a pool of APNIC community trainers. They will receive your question, and some people might pick up your question and answer to you. In today's training, we will use APNIC Academy to do the lab, and APNIC Academy platform is the free to public platform that includes some online courses, live webinars, virtual labs, and technical assistance. Also, all the APNIC events are listed in the APNIC Academy. So if you would like to find out any of our upcoming training events, workshop, then you can have a look on the Academy page. One of the features in the Academy page, we have the technical assistance. Technical assistance is in case you are a APNIC member and then you have some technical issue you would like to discuss with a certain expert. Maybe let's say you have IPv6 problem and then you would like to solve it, and then you would like to talk to an IPv6 expert, then you can go to this platform and book a session with IPv6 expert to discuss about your issue. For accessing the virtual lab in APNIC Academy, you will require to have an APNIC Academy account. So for any of you who did not have an Academy account yet, please go and register your Academy account. Here's the way that you can access the lab. You can visit to Academy and then go to the menu of courses, virtual labs, or access directly using specific virtual lab URL that we provide in the training materials page. And yes, after you register the account, you will be able to access it. You don't need to be an APNIC member to be an APNIC Academy member. So simply you just need an email address. You can register for the Academy account. And remember to allow pop-up for APNIC Academy website, because when you launch the lab, when you click launch, then Academy website will try to open a pop-up for showing the lab configuration console. So in that case, if your browser has pop-up blocking, then you will not see the window open. For all the labs in Academy are available 24/7. In case if we cannot finish some lab today in our session, you actually can save the progress and continue to do it at home or other day within 7 days. Like the presentation in OPM just now mentioned, APNIC policies the APNIC policies are developed by the members. So APNIC policies, actually not APNIC define it. All of you will define the APNIC policy, and then we'll have the discussion, and the community will finally reach to consensus before the policy is published. So if you would like to participate in the APNIC policy development process, you can visit apnic.net/community/policy/participate. Besides policy development, there are some other special interest groups that they discuss a specific topic using the mailing list. If you are interested, also you can visit orbit.apnic.net to explore what are the mailing lists available. APNIC also has our blog.apnic.net, which is APNIC blog. We often publish the blog post. And besides the blog also you can follow us in apnic.net/social for the social network that APNIC has presence. So this is just a short introduction slide for this training. Do you have any question before I go into the first presentation? Okay, so if there is no question at the moment, no problem. You can ask question anytime during our presentation by typing your question into the chat box. Then during the Q&A time, or if in case there is a chance, I will try to answer the question. So now I will go into our first presentation, which is talking about IPv6 protocol and address. Okay, let's go. So first of all, we will talk about IPv6 protocol architecture. And I believe many of you have experience in IPv4. The main difference between IPv4 and IPv6 is, first of all, the address length. IPv4 is 32 bits and IPv6 is 128 bits. Also, the way we write the IP is different. IPv4, we use the dotted decimal notation, which you can see like here, 192.0.2.1. And IPv6, we use the colon hexadecimal notation, which the number can be hexadecimal, can have A, B, C, D, E, F, and then we split them by the colon. Like this example, 2001 colon, DB8 colon, colon 1. And due to the length in IPv6 is longer, so IPv6 has much more addresses compared to IPv4. As you can see, IPv4 totally 4.3 billion, and IPv6 we have 340 trillion addresses. For address configuration in IPv4, two most common methods would be manual and DHCPv4, and for IPv6 we can use manual or stateless address auto configuration, or we call SLAC, or DHCPv6. In today's training, we will cover SLAC and DHCPv6. For routing protocols in IPv4, for IGP, normally it will be OSPF, version 2, and ISIS for the ISP. And EGP will be BGP. And for IPv6, we can use OSPF version 3 for IPv6. ISIS does support both IPv4 and IPv6. So if you are running ISIS for IPv4, you don't have to run another protocol. Simply enable ISIS address family for IPv6, then it should be fine. For BGP does support the IPv4 unicast and IPv6 unicast address family for internet routing. So if you are running BGP, also you can continue to use BGP. But of course, the best practice for running BGP for IPv6, it should be BGP over the IPv6 transport if your network supports. Here is a comparison between the IPv4 and IPv6 header. You can see there are some colors here. For the orange fields are the fields that not kept in IPv6, meaning this field is available in IPv4 but not in IPv6. Either they are no longer used or maybe other fields can perform their function. And there are some fields in green color here. They are renamed. For example, type of service became traffic class. For example, time to live became hop limit. And there are some fields remain the same, like source and destination address, they remain the same. For the blue field, flow level is the new field in IPv6. We will go through each field and explain what they are doing. For the version, it is a 4-bit field, and then version number is 6 because it is IPv6. And traffic class, it is used for defining the class of priority. It is similar to the type of service in IPv4 in case you need to do QoS. In IPv6, you can use the traffic class. Hello, can everyone still hear me? Okay, because I see my video is freezing, so I thought I'm disconnected. Okay, so I'll continue. Besides the traffic class, we have the flow level, which is a new field in IPv6. It allows IPv6 packets to be identified based on the flow. It is for QoS purpose. And in IPv6, there are some fields that are renamed. For example, payload length. Payload length in IPv4, it was the total length. And then in IPv6, it is only for the payload part. It does not include the header. This is because in IPv6, the header is fixed. So the payload length only talk about the payload. And if we would like to find out the whole packet length, it is very simple. You can simply just use the payload length plus the header, which is fixed, 40 bytes, then it would be the total length. While the total length in IPv6 actually includes the while the total length in IPv4 actually includes the IPv4 header. So this is the difference between the total length and the payload length. And there is another field, next header, which is 8-bit. It is used for identifying the type of information following the IPv6 header. It could be the upper layer header or it could be the extension header. It is similar to protocol field in IPv4. For example, in IPv4, if this is a TCP packet, then the protocol field will say TCP. So for IPv6, it is renamed to next header. Then in the next header field, you will see the value is equal to TCP. And for hop limit, it is similar to TTL in IPv4. Here are the example packet capture for IPv4 and IPv6. Let me try to open it and show it to you. Okay, so this is an IPv4 packet. So you can see this is the IPv4 header. There are the fields in the header, and IPv4 there are options and flags, which IPv6 no more. Now I will open another one for IPv6. This is for IPv6. This is IPv6 packet. You can see the header compared to IPv4. Actually, IPv6 is simpler because some fields in IPv4 are removed now in IPv6. And some fields are renamed, like protocol TCP, then in IPv6, it changed to be next header. And then like the time to live, it changed to be hop limit. IPv6 allows the optional extension header between the IPv6 header and the upper layer header, which can add the new features to the IPv6 protocol without major re-engineering. For example, the very common one that we might use would be the fragmentation. In IPv4, the fragmentation is included in the IPv4 header, while IPv6 fragmentation is an extension header which is separated from the IPv6 header. So when a packet is fragmented, you will see something like this. You will see in the packet has the IPv6 header, and then after that has the fragmentation header, then after that will be the payload. There are still other features besides fragmentation like source routing or ESP or AH or ICMP. There are other header values that can be in the next header field. And these are the extension headers: source routing, fragmentation, ESP, AH, hop by hop option. An IPv6 packet may carry none or many extension headers. A next header value of 6 or 17 indicates that there is no extension header. So if in the IPv6 header you can see here the next header is 6, then it means that there is no extension header. But if the next header is something else, which is the extension header number, then it means there is an extension header. Like here, next header is 44, it means there is a fragment header. Unless the next header value is 0, hop by hop option, the extension headers are processed only by the destination node specified by the destination address. So the routers along the way will not process the extension header unless it is a hop by hop option. And when there are more than one extension headers are used in the same packet, it is recommended that those headers appear in the following order in RFC 8200. So this RFC is recommending that if there are multiple extension headers, then they should be in this order: hop by hop, destination, routing, fragment, authentication header, encapsulating security payload header, and destination option header in this order. And finally, the last one would be the payload, either TCP or UDP. So it will look like this. And then you can see in the packet, if there is a hop by hop extension header following after the IPv6 header, then the next header value here will say 0 because 0 is hop by hop option. And then following the hop by hop option, if there is a destination option header, then it will have the next header value of 60. Then it means that the next header is the destination option header. And then here in the destination option header, there is a next header value of 43. It means that the next header is the routing. It is like daisy chain, one by one, following each other until finally there is no more extension header. Then the next header value will be either TCP or UDP. Here is an example packet capture for extension header. Let me open it. So if you open, then you can see here there is a fragment header for IPv6. This is the extension header for fragmentation. And then in this extension header, it is mentioning the next header is ICMPv6. So this is the payload. So you can see in the IPv6 header mentioned, the next header has the fragment header for IPv6, which is 44. And then in the fragmentation extension header, it mentions the next header is ICMPv6. And then this is the payload of ICMPv6. For fragmentation in IPv6, the handling is different from IPv4. Unlike IPv4, IPv6 fragmentation is only performed by the host or source node, not the routers along the path. And each source device needs to track the MTU size of each session. When an IPv6 host has large amount of data to be sent, it will be sent in a series of fragmented IPv6 packets. And basically, the IPv6 host will use the path MTU discovery or PMTUD to determine the most optimum MTU along the path. For example, as you can see in this diagram, from source to the destination, here the source, here the destination, the MTU of the interface is 1500. By default, it should send with 1500. But because of path MTU discovery, then finally it will receive the ICMP packet 2 bit error from one of the routers along the path, which has the smaller MTU. Then finally, the source will need to adjust the path MTU to be smaller to fit with the smallest MTU along the path. For example, in this case, if this link between these two routers is 1280, then the path MTU will be 1280. Yeah, thanks Awan for sharing the link. For any of you who would like to download the presentation slides, you can download from the link. This is an example of the path MTU discovery. First of all, in this diagram, you can see from here to here, from host 1 to host 2, along the path, all are 1500. But from router 2 to router 3, on this link, it is 1300. So if host 1 does not know about this, at the beginning, when host 1 wants to send a 2000 byte packet to host 2, then host 1 will use its default 1500 byte MTU to fragment the packet, because host 1 does not know yet here there is a 1300. So host 1 will send a packet with 1500, and then this is the packet. You can see the packet is 1500 bytes. And then finally arrive to router 1. It's okay because router 1 can send it to router 2. But when arrive to router 2 cannot send it to router 3 because 1300, which is the MTU between the router 2 and router 3, is smaller than the packet. So this packet cannot be transmitted. That's why router 2 will drop it, and then router 2 will send back an ICMP v6 error message saying that the packet size is too big and my MTU is 1300. So this packet will arrive back to the host, and then the host will receive it. Then finally, the host can adjust the MTU to be 1300 and then resend it again. This time it is 1300. Since it is smaller than 1500, so router 1 should be okay to handle it. And then finally go to router 2. And then router 2 also can handle it because from router 2 to router 3, it is 1300. And then the packet size is 1300. Then finally, the packet arrived to the destination, and the path MTU of this path is 1300 because of the path MTU discovery found that there is an error along the way, and then the smallest MTU of this path is 1300. That's why the whole path need to use 1300. Otherwise, it will not be able to send the packet to the destination. Okay, so up to this point, before I go to IPv6 address representation, any question for path MTU discovery or some IPv6 header I just explained just now? If there is no question, then I will continue to the IPv6 address representation. For IPv6, the address length is 128 bit, so it means the total number of address is this amount, and it represented with colon hexadecimal notation, which is like this. You can see each digit of number is hexadecimal. That's why it might have A, B, C, D, E, F, and then between them, they are separated by the colon. And in here, what I want to say, every 4 bit in IPv6 we call a nibble, which is a hexadecimal digit. For example, in this part A910. So for each digit A or 9 or 1 or 0, then it is 1 nibble. And then when 4 nibbles or 16 bits together, it will become 1 hex step. And then totally there are 8 hex steps. But here you don't see 8 because it is the abbreviation, and we will talk about abbreviation in the next few slides. For example, if you have an IPv6 address like this, there are some zeros in the address. Actually, the leading zeros can be omitted. Only the leading zero, not the ending zero. So like this case, B00 here, this one we cannot omit these zeros, but we can omit these zero, like 0db8 or 0000 to become like this. And a double column can replace contiguous hex segments of 0. So in case if you have multiple segments of 0, like 0, colon 0, colon 0, we can replace it to become colon, colon. But it can only be used once. You cannot replace 2 times.
Makito,
Yes.
before starting this slide, there is a question from Kinchuk. If you read, I can help you read that. Just take a look at the chat box. The question is, will path MTU increase transfer time?
This is not significant because actually path MTU discovery, this is the process in the IPv6. And on the internet, we cannot always expect that all the links will have the same MTU. So it is quite common that sometimes when the MTU is lower, then path MTU discovery will have to lower down the MTU from the source node. If normally if you send the packet and then along the way all the routers don't have any error, then it should be okay. Then you will not receive any ICMP error message. Then the packet will just travel directly to the destination. But if the router along the way send back the error message, then the source node will need to resend the packet again. There might be minor delay, but not significant, I would say.
Thank you. And just to add with Makito's reply, this happens once in a while, so it's not very frequent. So once the first packet is ready, it will go and send it to the destination. If something happens in between because of MTU, it will be back with an ICMP reply, and then the reply itself will contain the optimum MTU size. So once this is done, the subsequent packets are gonna maintain that. So it's very insignificant as mentioned by Makito. Hope that answered the question.
Yes, and also for one session after you discover the optimal path MTU, then you don't have to do again because the source node will cache the MTU number and then will send the packet with that smaller MTU. Okay, so for IPv6 address representation in RFC 5952, it recommends to replace the largest set of zeros with the colon for consistency. So in this case, so if you have here 3 sets of 0 and then here 2 sets of 0, then according to RFC 5952, you can replace the first one because this one has 3 zeros compared to this one, 2 zeros. We try to abbreviate the IPv6 address to be as short as possible. But in case if the number of zeros is the same, then the first set should be replaced. Let's say in this case, both are 2 zeros, then we will replace the first set, then it will become like this. But in reality, in some operating system, even if you type the lower one here, which we say not, it will still accept. But just according to the RFC, this is the best practice. For IPv6 prefix, it is similar to IPv4 that is using the CIDR notation, which is the IPv6 address / the prefix length. So in this case, for example, if we have the prefix of 2001 db8/32, then actually 2001 db8 is the IPv6 address. And then this is the /32, the 32-bit prefix. So this is the prefix, which is the first 32-bit of the address. 2001 0 db8 when we write in the binary will be like this. And then the remaining part will be the host part. For IPv6 address types, IPv6 has unicast, has multicast, and anycast, but there is no broadcast in IPv6. And there are several categories of unicast address that we need to know. For example, the unspecified address is :/128. This is equivalent to 0.0.0.0 in IPv4. And then for loopback ::1/128, it is equivalent to 127.0.0.1 in IPv4. And this is for embedding IPv4 into IPv6. And this is the most important one, global unicast 2000/3. This is basically the public IP address in IPv6. And I believe any of you that you apply for the IPv6 address either from APNIC or APNICIRINN, you will get the address from this pool from 2000/3. And there are still some other addresses like unique local FC00/7 and link local FE80/10. For multicast part, there are the assigned multicast address, which is FF00/8 and solicit hit node multicast address. This is used for the address resolution FF02::1 FF00/104. For anycast, actually most of the time anycast will use the unicast address, but you just deploy it in multiple nodes, multiple locations. For the global unicast address, the IANA or Internet Assigned Numbers Authority currently assign addresses only from the binary range starting with 001, which means this range 2000/3. And that APNIC has been allocated with 2400/12 from IMF. So most of the IP addresses, IPv6 addresses that the members got from APNIC will be from this pool, will be from 2400/12. And here is the reference link that you can have a look for IANA's IPv6 global unicast address assignments. For the global unicast address, normally the RIR, Regional Internet Registry, or National Internet Registry, NIR, will allocate /32 to ISPs and assign /48 to M-sites. The policy might be slightly different depending on each NIR, but generally for APNIC, we assign /32 to the service provider and /48 to the M-site. And then when the service provider got the /48, got the /32, the service provider can assign /48 or /56 or /60 further to their customers. Here you can see we use the word allocate /32 to ISP and assign /48 to M sites. This is because for the ISPs, they need to assign further to the customer. That's why when APNIC delegate the IP address to the ISP, APNIC is actually allocating this, not assigning directly to the end user. The difference between allocation and assignment would be allocation, you can further assign to someone else. For assignment, then this address is only for you. For IPv6 address auto configuration, there are stateless and stateful. For stateless, we use the stateless address auto configuration or SLAC, which the local router will send the router advertisement packets. And no manual configuration is required on the host. The host will receive the IPv6 information from the router advertisement packet, and then it will automatically generate the interface ID. Traditionally, it will generate with the EUI, modified EUI 64. But now, most of the modern operating system, they will do the pseudo-random method for the security and privacy purpose. Then finally, the 64-bit prefix that received from the router advertisement, plus the 64-bit interface ID that generated automatically locally, it will become a complete IPv6 address, which is 128-bit. I see a question. What is recommended for user side and ISP network inside network? I don't really get this question. Could you explain a little bit more what you want to ask? Maybe while you are writing the question, I will continue. Which IP range should we apply on user side? This is related or asking about subnet range. Okay. Actually, for the ISP, when you got a /32, after that you can do the subnetting, and then you can assign to the user based on your plan. There is no specific rule that how you can do it. But normally for the assignment for enterprise, it would be /48. It is a good practice. And for the smaller size like home user, it can be /60. The reason why that we recommend to assign /48 to the enterprise, because the enterprise, they might need to subnet it further inside their network to assign to maybe different branches or different buildings or different departments. And there is a benefit to use /48 for enterprise. When the enterprise use the address plan, then later, if they would like to migrate from the provider address to the provider independent address, they can still keep their own LAN planning, just simply change the prefix. So normally, if you are an ISP, it is recommended to assign /48 to enterprise customer. For the home user, depending on you, if you are more generous, you can give up to /56. Otherwise, you can give /60, but not a /64. Because /64, normally it is just for point-to-point. And then in case your home user, they have other connections, other LAN behind the CPE, then they don't have address to assign to their LAN if you give a /64 only. Home user, if we assign /60, will it not a wastage because it has many IP? It's okay. It's okay because in IPv6 you have a lot of IP. So just try to be generous. It's okay. You don't have to worry you run out of IP. Because as I think in the open policy meeting earlier also mentioned that if you run out of /32, actually you can apply further. So far, there is no strict limitation on IPv6 address that you can apply. So yes, just try to be generous. And then in the address assignment to customer also, you can try to make the sparse assignment. I mean, maybe when you assign to customer, you don't have to assign the continuous number like 0, 1, 2, 3 like this. You can assign one customer from this subnet and then another customer from that subnet. So it is easier for you to do load sharing in case you are an ISP. Can you explain again why we are not assigning the /64 to end user? It is because the /64 is point-to-point in IPv6. So if you assign only one /64 to the end user cannot further assign other address to the LAN. So it is better to assign at least maybe /63, or ideally you can assign /60 to your home user so they have more subnet that they can assign further to the LAN. Because you can imagine when the connection connect the internet to the user, then the user will need to assign the IP in their LAN network, and some user might have a bigger house, they might have multiple LANs. So in that case, a /64 will not be enough because we cannot do NAT in IPv6 like in IPv4. In IPv4, maybe the user will get one IP and then will do the NAT. No matter how many subnets for their LAN behind the public IP, they can do it, but not the case for IPv6. Because IPv6, the purpose is to use public IP most of the time. So that's why try to assign more address that can support your user to use public IP. Yeah.
Makito, can I add a little bit here?
Yes.
This is a good question, and we don't have much time to elaborate on any of the questions, but very quickly, for your enterprise customers, consider allocating a point-to-point address, and we'll come to that part when we are going to present the address planning. So for the enterprise customers, it's a point-to-point address is required, and that could be a /64, and from there you can use some smaller subnet. We'll explain later. And for the enterprise customers to be able to use within their network, you can allocate at least 1/48 that Makito already explained. Now coming to the question of users, home users, broadband customers. You can think of 1/64. There's not a problem if I assign 1/64 for the home users to be able to use it. But think about smart homes. Think about advanced users who has multiple subnets. Probably in your house, for example, you are an advanced user because you are a network engineer. So you probably don't want to put everything in one subnet or one VLAN. You might want to segregate, and you might want to utilize different subnets for different VLANs, and 1/60 might give your customers to create 16/64. That's enough probably, but in many countries, people allocate even bigger subnets. For example, a /56 in many countries. So be generous to give them more addresses, because this is insignificant numbers compared to the whole address that you have, a /32. It's a very big subnet you have. If you have less than that, for example, if you have a /48, still, if you do a proper planning, you can scale your network for very long time, even if you distribute a /60. Please don't do /64. At some point, you may need to renumber them. Your customers will be advanced, and then they will ask more address. And if you don't give them from the beginning, you have to renumber. That's a big problem as well. So yeah, please go ahead.
Yes, I also see a question: when all devices have live IP assigned, would it increase attack surface as it wasn't in IPv4 because of NAT? I would say you should do the filter if you worry about attack. Actually, in terms of security, IPv4 and IPv6 are quite similar. So some of the things that you would worry for IPv4, you need to do for IPv6. And for IPv4, if you are doing NAT, then maybe by default the firewall is doing the filter. Let's say if there is no mapping connection on the firewall, then the outside connection cannot reach to the internal network. Actually, you can do the same in IPv6 if you want. You can also place a firewall filter so that the connection can establish from inside to outside. And then if the connection is from outside back into inside, then you don't allow it if it is not a known connection. So technically it is doable, but just be careful when you are doing the filter, when you are running a server. For the end user, it should be okay. I mean, the end user, most of the time, they will connect to outside to get the resource.
One misunderstanding about NAT is that NAT actually doesn't provide any additional security, but people think NAT is a security kind of practice. If NAT could secure internet, the internet could be the most secure, the IPv4 internet could be the best secure internet in the world, right? But all the attacks, everything happens over that, right? So NAT doesn't provide any security if you don't have proper best security practices. So in that sense, even if you have more addresses, that doesn't necessarily add more devices. If I allocate a /60 to a customer, that doesn't actually add more live addresses unless they have really the need of the address and the device behind that. If I increase more and more device to the internet, I have to follow the practice of securing them. If I have a computer and if I click malicious email addresses, NET is not going to save my computer from being attacked, right? So yeah, human being means they will interact, and that means they will eventually, if they don't follow the best practices, they will eventually be affected. So yeah, it's a common myth that NET might add more security, but actually not really very helpful.
Yeah, NET itself doesn't add any security. The main point on NET just about if there is no mapping, then from the outside cannot initiate the connection to the user using private IP only. So that's why many people thought NET is more secure. Actually, you can do the same filter in IPv6. I see a question here, which prefix subnet have to advertise toward transit 32 or /48? I would say normally you can try to aggregate as much as you can. Maybe if you don't have the traffic engineering requirements, then you can advertise /32. But if you have to optimize the specific prefix, maybe not /48, it can be /40, /36, then you can do like in IPv4, you can advertise the subnet for the traffic engineering purpose. Otherwise, /32 would be sufficient. Earlier, I mentioned
we're going to
about
cover all this in our later section as well. So just please bear with us. These are coming in later slides, I think.
Yeah, we have a subnetting session. And just to add, the reason why I said try to assign /48 for enterprise, because one day this enterprise might go to APNICIRINN or APNIC to apply for the provider independent address. So if they are using /48 since the beginning, for them, they don't need to change a lot for the LAN planning. They simply change the prefix, then everything is okay. All right, so I will continue. Just now I talked about stateless configuration, and then now I will talk about stateful address configuration, which is using dynamic host configuration protocol version 6 or DHCPv6. It is able to track the address assignment compared to Slack, because you can see Slack here. Basically, the router does not track the address. The router simply sends the router advertisement saying its prefix, and then the host itself will generate the interface ID either with EUI64 or pseudo-random method, then will combine together, become a complete IPv6 address. So in this case, the router actually does not know that which host is using which address. It does not track the address assignment. Then in stateful, because of DHCP, it has the address tracking. So you can track, let's say you assign this address to this host. And then with DHCP also more other information can be obtained, such as DNS server or domain name, or even prefix delegation. For recording, I believe this session is recorded, if I'm not wrong. And then for the material, I think you can access through the link that I will share in the chat box. For IPv6, there are some difference compared to IPv4. For example, the URL syntax. Here you can see for IPv4, normally if we want to access to a web server with the IP address, we will directly type http:// and then the IPv4 address with the port number directly. But for IPv6, according to the RFC, then from IPv6 or later, the address will be enclosed by the square bracket like this. So it will be http:// and then the open bracket with the address and close bracket and then the port number. It is slightly different from IPv4. So if you don't have these two brackets in the URL, you will not be able to reach to the destination. And for IPv6 address in Windows, if you would like to check the address, you can use the ipconfig command in the Windows command prompt. Then you will see the IPv6 address. Normally, you should see at least two addresses. One is the IPv6 global unicast address. Another one is the IPv6 link local address. And then for Linux, you can use the command ifconfig. Then you will see the same. You will see two addresses. One is the global unicast, and then another one is the link local. For Windows, if you would like to ping to an IPv6 address, you can use the ping command with -6 here, and then the IPv6 address. Then you can ping to an IPv6 destination. For Linux, there is a command called ping6. Then you can ping to the IPv6 destination. And for the DNS query for IPv6, for IPv4, we use the A record for pointing from domain to IP, and for IPv6, we use the quad A record, which is A to point from domain name to an IP address. So to query the IPv6 domain name and get its IP address, normally you will need to query A or quad A record. In Windows, you can use the command of nslookup and then mention that the type of query is AAA and then mention the domain name, then you should see the address. And for Linux, you can use the dig command, mention that the record that you want to dig is AAA or quad A with the domain name. If you would like to dig from a specific DNS server, you can mention add specific DNS server address. Then you will get the answer like this. For example, this domain ping.group2.local is pointing to this address. Okay, so this presentation I have concluded. Any question before I move to the next presentation? The next one we will talk about, I believe we will talk about subnetting. Any question? Okay, so if no question, I will continue first. And in case you have any question, you just type into the chat box. What's the range of IP for IPv6 for multicast like IPv4? I believe in my previous presentation, I mentioned about that. Let me open it again. Here, this is the multicast address in IPv6. Okay, so I will move to the next presentation about IPv6 subnetting. In this presentation, we will talk about the subnetting of IPv6. What is link local address? Actually, link local address, this is the address that require for IPv6 to work. Basically, all the IPv6, you will need to have link local address. Without the link local address, this protocol itself will not work. And then link local address, it is the address just on top of the link. It cannot be routed. It is just for for example, the two directly connected devices, then they will be on the same link. Then this is the address for them to know each other. I think in IPv4 also you might use to see link local address. When you try to get IP from DHCP server and fail to get it, in Windows, sometimes it will automatically configure a link local address. So for IPv6, link local address became more important because we need to use link local address for the protocol. And also link local address also widely used in terms of routing protocol. Let's say you are running the routing protocol of OSPF, then you will need to use the link local address. What is the loopback address for IPv6? Okay, I believe I mentioned in the previous slide, but I will just quickly answer here. It is ::1/128. This is the loopback address. How to do NS lookup of IPv6 in state domain in CMD? Actually, if you want to query the IPv6 domain, you can use NS lookup. Yeah, you can use any lookup. You just mention about the record that you want to query. The record that you want to query is port A, then it is for IPv6. By default, it is to IPv4, like A record, it is for IPv4. But if you are referring to the reverse DNS, you want to query from the IP back to the domain, then you need to query the PTR record, pointer record. Okay, yes. So if the reverse query, you just use the pointer record. And then I believe the extension is IP6 because IPv4 it has the address.rpa extension, and then for IPv6 the domain is IP6. Can you see my PowerPoint? Now I am trying to change the slide. Okay, so if there is no more question, then I will go to the subnetting part. In this presentation, we will talk about IPv6 address subnetting introduction and subnet calculation of /32 and /48 and the neighbor boundary. So what is subnetting? Subnetting, it is the practice of dividing a network into two or more networks. For example, let's say there is a /32 and then we divide it into multiple /36, multiple smaller network, then this is subnetting. And then, for example, if you have an ISP network and then you receive a /32 and then you would like to subnet to multiple regions of your network, then you actually can subnet it. For example, you can subnet to /40 for each region. And then the way of subnetting is like this. This is a /32 and then you will subnet into /40. So the prefix currently that you have is 32-bit, but you would like to subnet to 40-bit. So actually the difference between them is 8-bit. These 8 bits are for subnets. So you can see because of the subnet is 40-bit and then your original prefix is 32-bit, then you totally can subnet into 256 subnets because 2 to the power 8, then you can get 256 subnets from /32 to /40. And then if we see in binary, actually each digit here is 4-bit. So starting from here, it is the bit number 33, 34, 35, 36 until bit 40. And then if you subnet it into /40, then it will be like this for each region, starting from 0 until 1, 2, 3. If in binary, it is like that. So each time you will increase 1 bit. Then if we convert into the hexadecimal, it will become 0, 0, 0, 1, 0, 2, 0, 3. Actually, if you are subnetting with the neighbor boundary, I mean, from 32-bit become 40-bit, it is 2 neighbor. So in this case, actually, you can directly count the number. You don't have to convert into binary and then convert back into hex. It is not necessary. You can directly count 0/40, 0100/40, 0200/40. It's okay until 0F00. And then after that, it will become 10, 1112. So if you subnet the /32 into multiple regions of /40, it will become like this. Because /40 is up to here, up to the orange part. Let me draw it. /40 is up to here. If you subnet to /44, you can use up to here. If you subnet to /48, you can use up to here. So basically, if you subnet to /40, the simplest way without converting to binary would be, here are 2 bits that you can use for your subnet. Here are 2 digits that you can use for your subnet. Then these 2 digits, actually, each digit is 4-bit and then totally 8-bit. Then you can count it 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, like that. You can subnet to /40. In case if you subnet to /44, it is also the same. You will start from 000, and then here becomes 001, 002, 003, 004, 005, like that. Then you can subnet to /44. This is easy. But if you are subnetting like, for example, /35, /37, /39, then you might need to convert to binary because you cannot simply just count the number like that. So now we know if we subnet from /32 to /40, we can do this way. And then how about subnetting to /48? In /32, there is one /32. And then in /32, there are 16 /36. Because between /32 and /36, there are 4 bits. And then 2 to the power 4, then it will be 16. Sounds like someone is on a call. Is there any problem with my voice? Okay. If there is any problem with my voice, please let me know. So if you are subnetting to /36, basically it will be 1 digit here because it is 4 bit. It is 1 nibble. So it is easy. You can count 0, 1, 2, 3, 4, 5, 6 like this without converting to binary. And then to 40 also the same, just like what we did just now. We can count the number because it is exactly 8 bit. So it is 2 nibble, 2 digits here. Then we just simply count 0, 1, 0, 2, 0, 3 until FF. For /44 also okay. It is just another extra digit that you can use for counting the subnet. It will be 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3. And then for /48, then basically it is another extra digit that you can use. It will be 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 2 until finally FFFF. So you can see 1 /32, actually you can have 16 /36, 256 /40, 4096 /44, and 65,536 /48. So even if you are an ISP that you have many enterprise customers, actually you can support up to more than 60,000 customers within 1 /32. So that's why for the address assignment, you don't have to be stingy. You can be generous. You can try to give the bigger pool to the customer. And then sometimes in IPv6, because we have plenty of addresses, then we can have more meaningful design. Or maybe the address will be easier to memorize if you design properly. For example, you can divide your network into multiple /36, and then for all the infrastructure link, you put in the prefix number 1, and then for all the point-to-point link, you put into prefix number 2, and then for all the extra prefix that you route to customer, you put into prefix number 3. This kind of design, you can do it, and it is easy. When you see the number of the subnet, you immediately know what it is. Not like in IPv4, because in IPv4 normally you might have a /24 and then you need to put a lot of things in the same subnet. It can be point-to-point link mixing with the customer routed subnet, but in IPv6 you can divide them into different /36. How we can calculate /64 from /32? How much addresses are covered? Basically, if you want to know how many /64 you can divide from a /32, you just need to use 64-bit minus 32-bit, then you will have 32-bit left for the subnet. Then you can use 2 to the power of 32, then you will know how many /64 you will have. But in reality, for the ISP address planning, you might not plan directly to the /64 in this way. You might plan it maybe based on the region. Let's say, like in our example just now, we plan based on the region. Each region is the /40. And then in that region /40, maybe you will put some /48 for the enterprise, and then you will only use one /48 for the end user that will use /64. So in that case, your calculation will be between /48 to /64, will not be directly from /32 to /64. Actually, we have another presentation about the address planning, but I think today, due to the time limitation, we might not have time to cover that presentation, but I put it as the resource in our training materials. Let me open it and then show it to you. I think it is straightforward that you can read it directly because it is just step by step for address planning. It is self-explanatory and it doesn't require me to do the presentation. This is the address planning slide, and then in here mentioned about subnetting, and also it mentioned about the ISP address planning. Let's say if you are assigning the /48, /52, /56, and how you should plan, how you should put your customer. In this case, this is the sparse assignment that I mentioned earlier. I mean, instead of you put a lot of customer in one block like this, try to put them in different block if possible. Then it is more flexible for you to do traffic engineering. In this presentation, mentioned about how you can plan for the ISP, starting from the ISP infrastructure to the point-to-point link, to the NOC, and then finally to your customer IP address. And besides the ISP, there are the enterprise example also. You also can see from this presentation, if you are an enterprise customer, then how you should do the plan for your network. Also, it includes the example of data center. Yeah, just have a look in the presentation. It is a quite long presentation with 86 slides due to the time limitation because we have only 4 hours in today's training. That's why we cannot cover all the slides. If we have 250 or 500 users per VLAN, then how to make the subnetting? You have 200, 500 users per VLAN. I think in IPv6, the mindset of subnetting is different from IPv4. IPv4, we usually need to consider how many users we need to support in each subnet. But in IPv6, technically, you can support up to 2 to the power of 64 users in 1/64. So in reality, you will never run out of IP address in the same subnet. That's why instead of thinking how many users, you should think how many VLANs. How many VLANs or how many subnets you want to divide. So if let's say you have 100 VLANs, then you just make 100/64. It is straightforward. You don't have to consider in each /64 how many users, because in the same /64, most of the time I would say you will not run out of the IP address. Can we assign /126 IP to end customer? Yes, you can. You can assign /126 to customer, but this 126 has only 4 IPs. And most of the time, I would say for the enterprise customer, if you assign the IP to them, you will make a point-to-point link, which can be a /127 or /126 or /64, depending on the operating system that you use. For example, Cisco and Juniper, they support /127. So in this case, you can assign a /127 as the point-to-point link, and then you can route an extra maybe /56 or /48 to the customer, depending on the size of the customer. If they are the enterprise, then route a /48 to them on top of that, not just one point-to-point link. This is different from IPv4 because in IPv4 we can do mapping. So when you assign a /30 to customer, they have only one IP, then they can map to many LANs. But in IPv6, this is not the case. That's why in IPv6, normally, in addition to the point-to-point link that you connect to customer, you will assign another extra subnet, maybe /48 or /56, depending on the size of the customer. I see another question. What is the minimum IPv6 subnet that can be used for BGP advertisements? It will be /48. /48, you cannot advertise /49 to the internet. Most of the ISPs will not accept more than /48. Then if you have smaller than /48, you advertise to your upstream, it is likely that they will not accept it. This is also the reason why we recommend to give /48 to the enterprise customer. So one day, if you want to do traffic engineering against this enterprise customer, for example, you have a lot of enterprise customer, but one customer is complaining that they are having the high latency to a certain destination, and you would like to optimize the inbound traffic path. Then in this case, you can advertise this /48 specifically to a specific link that you believe it has the lower latency. So there are some benefits of assigning /48 to the customer, not only for them to easily remember, but also for ISP easy to do traffic engineering. Please explain slowly. Sorry, because of the time limitation. That's why I try to spend less time in each question because we got a lot of questions. For point-to-point link, yes, our answer MikroTik you can use /126 because MikroTik does not support 127. For the training material, you can see from the training materials page. Basically, all the things that I shared today, including the presentation slide just now, all are available on the training material page. The presentation that I shared just now is the IPv6 planning. You can see on the session 1, the right side of session 1. Let me open the page. In this training material page, if you go to session 1 IPv6 subnetting, the one that I am presenting is this one talking about subnetting, and then there is another one which is IPv6 address planning. This one is the example that I showed just now, planning for the ISP, for the enterprise, and for the data center. You can download the presentation slide from here. Basically, all the slides are available for downloading. IPv6 uses path MTU discovery to determine the most optimal MTU along the path. Yes, it is correct. Because if along the path there is a smaller MTU link, then the source will receive the ICMP error, and then it will optimize the MTU based on the information in the error message. For point-to-point, okay, this is Awal's answer. Okay, thank you, Awal. So I will move back to my presentation. Yes, so this is what I showed just now from /32. If you want to subnet into different prefix length, you can get these amounts of subnets. So for example, just now if we divide the /32 into /40 in each region, if you use /40 in each region, then it means that in your /40 you will be able to support 256/48. And then in your /32 you will be able to support 256/40. So you can imagine you will have up to 256 regions. And then in each region, you can support up to 256 enterprise customer. This is in case of /40. Sure, you can adjust based on your requirement. It doesn't mean that every region must be /40. You just need to have the consistency throughout your network. If you have less regions to cover, but more customers in each region, then in that case, you can subnet to /36 per region, then you can support 16 regions and 4,000 customers per region. I can see there are a lot of questions, and sorry if during my presentation I cannot answer the question promptly. Also, thanks to my colleague Awal and Imtiaz, they are happy to answer the question. So yes, if you have any question that we cannot answer on time, sorry for that. We will try to answer as much as we can. So if a customer got a /48, then how to subnet it further? Actually, it can be /52 like this. Actually, the concept is the same. You can see even /32 or /48. When we increase by 4 bit, then actually it is 1 digit here. So if we increase by 8 bit, it will be 2 digits here. So if /48 subnet to /52, you will just count 0, 1, 2, 3, 4 like that. So it will be 0/52, 1000/52, 2000/52, so on and so forth until finally you got 16/52. And for /56, it will be 2 digits. So you will be counting from 0, 0 until FF. Finally, you will have 256/56. How to verify an IPv6 address is unique. This one we will talk about it in the next presentation. We talk about neighbor discovery, and then we will talk about duplicate address detection. There is a mechanism to detect. And this is for /60. /60 basically count from 000 until FFF. You will have 4,000 prefixes in /48. And then /64, you will have 65,536. Again, you might see I try to jump 4 bit by 4 bit. It is because when we do the subnet 4 bit by 4 bit like this, then it is easy. It is easy that you don't have to convert to binary and then convert back to the hexadecimal. You can simply just count 1, 2, 3, 4, 5 like that. Then you can have all the subnets. So if you are an enterprise, you have a /48, and then you would like to subnet further. Let's say you would like to subnet up to /64, then you can have 65,000 subnets, 65,000 VLANs. But in reality, you might want to divide. When you are an enterprise, you might want to divide. For example, you might have the office in multiple regions, or maybe multiple office buildings. Then in that case, you might divide it further to a /52 or /56. Or maybe you might want to divide based on the department. Here we are not saying that what is the best way to divide. It is depending on you, because IPv6 is so flexible. You have so many bits that you can play on it. So you just can make your most optimal design. You can use your creativity to make the best design that suit with your requirements. And a little bit about neighbor boundary.
Makito.
Yes.
There was a question from Sapana Kumar. What is the range of IP v6 multicast address? Did you cover the answer? I'm not so sure.
Yes, I showed it earlier.
Oh, okay. Sorry. Yeah. Go ahead.
Yeah, I'm sorry because I can see there are many questions and all of you are very active. Thanks for this. Yes, I'm sorry during the presentation, maybe sometimes I did not see the question and then cannot answer it in real time. Maybe my colleagues will try to answer in chat box if they can help. So for IPv6, when we do subnet, the reason why we try to do with neighbor boundary, because one neighbor is 1 digit here. So it is easy for us to simply count 1, 2, 3, 4 like that. Because if it is not a neighbor, now this is an example of neighbor, that if it is not a neighbor, you will need to convert it into the binary. If it is a neighbor like this, you don't have to go through this step because it is 4 bit anyway, you can count. But if it is not /36, this is an example of /36. If it is /35, now we are talking about /35, which does not cover the entire neighbor. You can see the bit that you are trying to subnet is 3 bit here. So you will need to calculate it with binary. You will need to calculate and then you will need to count it in binary, and then finally you will convert it back to the hexadecimal. It will be like this. Sure, for me, as the person working in the industry for a long time, I might not calculate like this. I might use a subnet calculator, or maybe I will remember 1/35 equal to 2/36. So When I count the number, I will simply count 0, 2, 4, 6, 8 by skipping one number in between. So this is also the way if you don't want to convert to binary and then convert it back to hexadecimal. But just want to show that in case if it does not complete one nibble in your subnet plan, then you will likely to calculate with the binary. So subnetting with nibble boundary is good and it is recommended. It is recommended to do as long as it can fulfill your requirement. I think for personal experience, if you have a /32 for the ISP, actually it should be more than enough to make a meaningful and very creative address planning with nibble boundary. You don't really need to run into some very strange prefix length like /43 or /35. And you can simply just use 36, 40, 44, 48. It is easy. Maybe this one for the region, this one for the service, this one for the customer, enterprise customer, something like that. IPsec is supported in IPv6. Yes, it is supported in IPv6. And IPv6 has blocons or not? Yes, of course. IPv6 also has blocons. Okay, so I finished my second presentation. If you have any question that you still did not ask yet, you can ask while I am switching to the third presentation. Again, I am sorry that if I am speaking fast or maybe cannot answer the question completely, because today actually our training time is only 4 hours, and then we are trying to fit in the content into these 4 hours. The content that we are delivering in normal training, we usually deliver with 1 day. So yeah, because of the time limitation, and then we don't want to cut the topic also, because when we receive the request, we see you want to have the subnetting topic, you want to have transition technology, you want to have the configuration. So we don't want to remove any topic. We try the best to cover all the topic, but due to the time limitation, then probably some topic we cannot go too deep into it. But I put all the resources in the training materials page that you can refer to it anytime later. I hope it would be beneficial for you. Yeah, there are some presentation. Let me quickly open the training material page if I can. Then you can have a look. Some presentations that I recommend to have a look if you would like to have more understanding. Let me go to the link. Yes, and you can see just now I present about IPv6 protocol and address and subnetting. Actually, there are a few more detailed presentations like extension header and address type and address planning. You can have a look on it. For example, like address type here has the very detailed about address type. Because just now in my presentation slide, I use only one slide to talk about each address type. But in this address type presentation, there are 111 slides talking about each different address type, from unicast to multicast, and then talking about how to generate the interface ID, for example, how to generate the EUI64 interface ID from the MAC address. This is very detailed on the address type part. So you can have a look if you are interested. And for the extension header also, there is another presentation about that. For the IPv6 planning, it is the one that I showed you just now. Is there any way to get this meeting recording? I think the host will be able to answer this question. Okay. Yes. Okay, thanks, Awal, answering some questions. And then next, I will continue to another presentation, which is neighbor discovery and address auto configuration. This presentation will talk about one thing that we mentioned earlier about duplicate address detection when we configure the address, how to know whether it is conflicting with other addresses on the link. In this presentation, we will talk about IPv6 message for neighbor discovery and IPv6 address auto configuration. First, IPv6. One thing that ICMP in IPv6 is very different from IPv4.
Sorry to interrupt you. There are some participants that have their hands raised. So not so sure. For example, Aditya Singh probably has a question, or Ashwathi. They have
Okay, for the participant that raised the hand, do you have any question? If you have, please ask your question. Maybe you can ask your question now.
I can see Aditya Singh has his hands raised.
Yeah, hi everyone.
Yeah, sure. Go ahead.
I want to generate subnetting, but we are facing issues. Can you provide any tools for the subnetting generation?
Subnetting tool.
Yeah, subnetting generation tools, because I want to implement in the Linux, but we are still issue not getting thing of IPv6.
Yeah, so what you can do is I would suggest you use IP address management tools, for example.
I want to know that what is the difference between IPv6 subnetting and IPv6? Because here is Linux operating system. There is only show IPv6, not IPv6 subnetting options.
So I'm a little bit confused about these terms. For example, IPv6 and IPv6 subnetting.
Yeah.
They doesn't go like one is not a kind of a replacement to another one. So it's like for example, address itself is IPv6 address. And then when you have a big address and you need to create multiple smaller network, that's called subnetting. It's the same concept like IPv4. So let's say you have a /32 big IPv6 address.
To create a I have a /48 pool for IPv6, but I want to create a 256 IPs.
Okay. So I understand the question and I'll answer it briefly. Please feel free to reach out to us later on if you want, because this is gonna take time. What I understand is that I may need more time to explain this to you. This is a question which is inbuilt answered, but since you asked this again, so let me take like 2 minutes. Sorry, less than 1 minute quickly from Makito's time. Sorry, Makito, just taking your time. Yeah. So when you think about IPv4, you think about number of hosts and what is the subnet for that number of hosts. When you talk about IPv6, forget about the number of hosts. Don't think about I have 500 sub users in a network. Forget about this, because each LAN is a /64. That covers trillions and trillions and addresses. Doesn't matter whether 500 users there or 1 billion people there. Doesn't matter. It's just 1/64. So one subnet, 1/64. Now, if you want to start subnetting like this concept, that will not work, because if you have a big land and you want to make a house, you cannot just start building your house from one corner of the house. You have to make first a master plan of the whole land, and then start building which one is you need now and which one you want to build later. So that is what comes when we do subnetting with IPv6 address. So if you have detailed question about this, we may talk about it later. So we have our email addresses on the website that we shared. Please reach out to us and then we can talk to you about this.
Okay, thanks, Abdul sir. So,
but I think you got an idea, right? You got your answer at least.
Okay.
Is it?
Okay.
Did you get some idea? I mean, did you got your answer briefly?
Sure, I want to know that why the difference between IPv6 subnetting and IPv6. I cannot understand IPv6 subnetting and IPv6. What is the difference between IPv6 and IPv6 subnetting? Because I have a many time tried to create IPv6 and IPv6 subnetting, but still I am not getting ping on our Linux server.
Okay, so I think that there is a concept confusion here. So there is no, you know, if you want to make differentiation between two things, there has to be similar concept, right? So IPv6 is the whole concept, and IPv6 subnetting is a smaller part of the big concept that just specifically required when you want to make multiple LAN with your one big IPv6 address. So the IPv6 is the whole address, and subnets are the smaller parts of a big address. But that's a brief answer. I understand you need more, bigger discussion. We will do it. Please send us an email to the email addresses that we have.
Thank you so much, Mr. Abdul. I will going to emails and
get back. We'll get our response very quickly once you send an email, and we'll talk about it later. No problem at all.
Sure. Thank you so much, sir. Thanks.
No problem. Sorry, Makito, over to you.
Okay. So I will continue. Basically, just now about the subnetting question. Again, for IPv6 subnetting, you don't have to consider how many users in one subnet. You just need to consider how many subnets you want, because technically you will not run out of 2 to the power of 64 addresses. You will not have so many users in one subnet. So just consider if you want 100 VLANs, then it will be 100 prefixes for the IPv6 subnetting plan. Okay, so I will continue the presentation. IPv6 ICMP is different from IPv4 because in IPv4, maybe I think many of you will have the impression that ICMP is you will see it when you are pinging something, or maybe you will see it when the packet is too big, you receive the error message, or sometimes you ping to the destination, you receive port unreachable, host unreachable, this kind of message just for diagnostic purpose. But for IPv6, actually ICMP-v6 is a very key component. And without ICMP-v6, IPv6 will not work. IPv4 will work if you filter ICMP, but IPv6 will not work if you filter ICMP. So you cannot drop all the ICMP in IPv6. Maybe you can selectively rate limit or drop specific type of ICMP, but not all. And main ICMP-v6 messages that we use in IPv6 neighbor discovery are following: router solicitation or RS message. It is the message that when the host is connected to the network, you can imagine your PC is connecting to the Wi-Fi, and then once it is connected, normally your PC will send a message of router solicitation. Basically, it is like saying, hey, router, please send me your router advertisement. I am a new member in this link. I want to configure my IP. It is like that. So this is for router solicitation. And then router advertisement, it is the message that advertised by the router. By default, the router will advertise it with specific interval. Then if the router did not arrive to the time that the router will advertise this RA message, and the client, the host is sending the router solicitation message, the router will also advertise the router advertisement message if it receives the router solicitation. It contains the prefix information and the default gateway. Like we mentioned, IPv6 can be automatically configured using stateless address auto configuration. And that it is based on the information in the router advertisement message that the router sent on the link. And in case the router did not send, then yes, we need to send router solicitation to ask for the router advertisement. Another type that we use in IPv6 is neighbor solicitation. This is for resolving the link layer address. It is like ARP in IPv4. Basically, you have an IPv6 address. You need to look for the MAC address of this IPv6 address in order to encapsulate the packet and send to the destination. So it is neighbor solicitation. Can you hear me? Or is the audio still low?
I think it's okay, but just thinking if Bikram, you have any local issue, because it's quite clear from our side, and also some participants already replied. So maybe check your end. Might be low volume or something like this. Yeah.
Okay. Okay, so for neighbor solicitation, this is for requesting the link layer address. It is like app request. And then neighbor advertisement, it is for sending your link layer address. For example, in this case, host 2 is telling host 1, my link layer address is this MAC address. It is like app reply. So in IPv6, you can see app request and app reply are based on ICMPv6. So you cannot really drop all the ICMPv6. Then if you drop all the ICMPv6, even the link layer address resolution will not work. And the redirect message is in case in one network, there are multiple routers, and then host 1 is going to router 1, but router 1 find out that host 2 should go to router 2 for a more optimal path. Then router 1 will send a redirect message and tell the host 1, hey, you go to router 2 to use it as the gateway. These 5 messages are used in IPv6. Again, router solicitation, RS, router advertisement, RA. These two are for configuring the address. And then neighbor solicitation, NS, and neighbor advertisement, NA. These two are for the link layer address resolution. So let's have a look how we can configure the IPv6 address. We can do the manual configuration. This is just the same as IPv4. You just manually type in your IPv6 address and the default gateway and the prefix length. In IPv6, we no longer use the subnet mask. We will use the prefix length, which is similar to the CIDR notation of the subnet mask in IPv4. And besides the manual configuration, you can do the auto configuration using stateful or stateless. Stateless means you will configure based on the information in router advertisement, and then the host will automatically configure the IP without involving another address configuration server like DHCP. For stateful, we will use a DHCP server. Let's see how it works. The difference between stateless and stateful, it is for the stateful, it will use DHCP. And then for the stateful, then you can send other information besides the address. For example, if you would like to send like the DNS server, you would like to send the name, the domain name, then it will involve the DHCP. And actually, both of them can be used simultaneously. Here, I will show the detail about, actually, there is one option between stateless and stateful. I mean, stateless, you can configure the address, and then stateful, you will use DHCP server to delegate the address and all the things. There is one thing in between is you can use stateless to configure the address, and then you can get the domain name and DNS from DHCP. We will explore more in the next few slides. Here we will talk about stateless first. For the stateless address auto configuration, basically you don't need to configure anything. When you connect your PC into the network or when you connect to the Wi-Fi, then your host will automatically receive the router advertisement. But if it does not receive, it will send router solicitation to get the router advertisement. And then based on the information of router advertisement, it will configure the address like this. This is the prefix that's sent by the router, included in the router advertisement message. And then the remaining 64-bit interface ID, it is the host generated one, which the host will automatically generate it by itself. Previously, maybe at the beginning when IPv6 came out, then it will use the modified EUI64, which means it will cut the MAC address into two parts and then add FFFE and then flip the 7th bit That was the traditional way for configuring the interface ID. But now it is more like pseudo-random, more like randomly configure the interface ID. Because if you use the MAC address to configure the interface ID, other people can easily find out what is the MAC address of this address. And also, if it is not random, let's say I am Makito, and then my MAC address will not change no matter which network I connected to. So maybe I access a website in Australia, and then I access another website in US, and I access another website in Cambodia. Then finally, when see the log file, can see all of these access are from Makito because the interface ID is the same, no matter Makito is connecting to an Australian network, an American network, or a Cambodian network. Based on the interface ID, they can identify this is Makito. That's why there is a pseudo-random method currently that the OS will randomly generate. That's why we can no longer track whether this is the same person. So with the stateless configuration, it is straightforward. Just receive the prefix from the router and then configure the interface ID that is automatically generated by the host. Then it will become a 128-bit address. For stateful configuration, it relies on a DHCP server. That the DHCP server will tell which address to configure. And then in addition to the address, DHCP server can also give information like DNS server or other things like domain name. There are some additional information. Also, we can use one method which is in between Slack and stateful DHCP v6. We can use Slack to configure the address, which means the address is stateless. But for the DNS and other things, additional information we can obtain from the DHCP server. So this is in between. You can see again for the stateless, this one only for configuring the address. There is no DHCP. And then for stateful with DHCP server, you can get everything from DHCP. And then there is a method in between. You can use stateless to configure the address and only get DNS server or other additional information besides the address from the DHCP server. Then there might be a question that which is the good method to use. Actually, it depends on the requirements. Most of the time, if you don't need to track the address of the client, then I would say stateless address auto configuration is more than enough. Only in the case that you want to bind, for example, in DHCP, you can bind the MAC address with a specific IP. You want to say that this guy, I will always assign the same IP to him, then you can use DHCP to achieve this. So first of all, before anything happens, the host will create a link local address for itself, starting with FE80 and then with the random interface ID. And then when it created the address, in order to know whether this address is in use or not, then it will use a mechanism called duplicate address detection or DAD to verify. Basically, the way it verifies is like this. It will send a neighbor solicitation to the network asking anyone using this address. This is the neighbor solicitation packet capture. You can see it is ICMP v6 type 135, which is neighbor solicitation. And then the target address is the address that it intended to use. And then guess what? If no one answers, then it's okay. It means that this address is unique. Because as we learned earlier, neighbor solicitation is used for resolving the link layer address. It is like app request. It is like asking that anyone have this IP, give me your link layer address. If no one replies, then it means no one is using this IP. So it means you can safely use this IP. Otherwise, if someone replies, then the host will need to change the address. Maybe it will generate another address. Then it will try again with the duplicate address detection. Will send neighbor solicitation again, asking anyone using until no one is answering. Then it will use this address. For the global unicast, For the global unicast, the host will send router solicitation message. If it does not receive the router advertisement from the router, then this is the ICMP 133. Inside this message, actually it doesn't have a lot of content because mainly it is just looking for the router. Say that, hey, if you are the router, send me your router advertisement. And then the router will send back the router advertisement. And then in the router advertisement, this is very important. There are two fields here, M field and O field. M is the managed address configuration, and the O is the other configuration. And then there can be three situations you can see. If M is 0 and O is 0, then this one is the stateless address configuration. If M is 0 and O is 1, then this one is the stateless configuration plus other information from DHCP. And if M is 1, it means that take everything from DHCP. Then it will not care about O anymore. So very simple. If both M and O are 0, it will not use DHCP. It will do Slack only. If M is 0 and O is 1, it will use Slack to do IP address configuration, and then it will get DNS and other things from DHCP. So it will partially use DHCP. If M is 1, it will use everything from DHCP. So we can see in case M is 0 and O is 0, then what will happen? The router will send back the router advertisement like this. M is 0, O is 0, and then this is the router's prefix. And then this is the packet capture you can see in router advertisement, which is ICMP type 134. And then this is the M flag and O flag, both are 0 here. Manage address and other configuration, both are 0. And then it contains a prefix information, which is 2001 DB81/64. Then the host will use this prefix and then will generate interface ID and then combine together. Then it will become a global unicast address. It will be configured automatically by the host. The router does not even need to know what address the host is using. So this is also having one advantage. When you are having many hosts, you can imagine if you have thousands and thousands of users in the same subnet. For IPv4, when you are assigning with DHCP, your DHCP server will need to keep the status of all the addresses. But in IPv6, you don't have to care this. As long as you don't need to track the address, then even there are a million users in the subnet, then your server, basically your router does not need to track anything. Even you use a DHCP server to give DNS information, also your DHCP server does not need to track each and every address, unless you are using the stateful DHCP that you assign everything from DHCP. So this is the example of getting address through Slack. I got a question, how many reserve stack in IPv6? What do you mean in this question? Maybe you can add a little bit more details, then I will come back to this question. Any fixed IPv6 address, or do you mean you want to reserve some IPv6 addresses within the same subnet for some specific host? Like in IPv4, you can set a pool and then you reserve certain IP for some specific MAC address, and then you can bind them to get the static assignment. Are you referring to this? If you have this requirement, then you will need to use DHCP v6, because stateless address auto configuration cannot track the address. So actually the router cannot know that what address the client will configure. The router simply say that, hey, this is my prefix, and then you configure the IP by yourself. As long as it works and then not duplicate with other people, then I don't care. It is like that. So if you have specific requirement that you need to manage the address to be assigned, then DHCP is the way to go. Okay, then here is stateless DHCP v6. Stateless DHCP v6, it is, we don't use DHCP to assign the address. It is in between the stateful DHCP and the SLAC. We use the SLAC to assign the address, and then we simply ask DNS information from DHCP. Because SLAC cannot configure DNS information, so we will do this. When send the router solicitation, and then the router will send back router advertisement. And then in the router advertisement, the router will mention that please obtain other configuration from me, from the DHCP server, not from me, from DHCP server. In some cases, maybe the server and the router are the same, then it is from me. But if the server is not the same, then it is from the server. Okay, so when the other configuration is set to 1, then it means that besides the address, you need to get something from the DHCP server, which can be a separate server or can be on the same router if the router is running DHCP. Then it will configure the address like SLAC, and then after that, it will request through the DHCP to get other information. If you would like to know more about DHCP, can refer to this RFC. I would say most of the things, to my impression, DHCP v6 are quite similar to DHCP v4. Sure, they are the difference, but you can refer to the RFC for more details about how it works. And in our presentation, I believe we have another presentation talk more about DHCP, but we don't go into the detail of DHCP. I mean the step-by-step of DHCP in this slide, because mainly we just need to understand the concept of it. So when you get the address through SLAC and then you get the DNS from DHCP, then it will be like this. You will have DNS in your IPv6 configuration. And then in case M is 1 and O is 0 or 1, this is ignored. Regardless O is 0 or 1, then the client will get everything from DHCP. So basically, when it sends the router solicitation and then get back the router advertisement, if the router advertisement is saying that manage address configuration is 1, then it will get everything from DHCP. Then this one will be similar to DHCP v4, which you can manage all the things with DHCP. I would say most of the time, if you don't care about what IP address your client is getting, then you don't have to use the DHCP to manage the address. Because when you use DHCP to manage the address, you will need to store the status on the DHCP server. If you have 1,000 users, you will have 1,000 records on your DHCP server. For example, in this case, this IP is assigned by DHCP server, and then on the DHCP server, I believe this is a router running DHCP server, a Cisco router, then you will have a record on it. So you can imagine when you have a lot of users, then your server will need to keep a lot of records. So just consider whether it is necessary to track everyone's address or whether it is necessary to do some address binding, manual binding. If not, then SLAC is the way to go. And DHCP simply used for giving the DNS and other information. Okay, that's it for this presentation. Any question before we move into the lab? And by the way, because along the way we got a lot of questions, I might need to use some of your break time to do the lab. I hope it is okay for you, because originally we planned to have a 30 minutes break from 2 o'clock to 2:30 Indian time. But I guess if we will start the lab now, I might need to use some of your break time to show the live demo of the lab. So if everyone is okay, let me know, or otherwise, I will leave it to you. I mean, the lab, actually, it is a self-paced lab that you can try anytime. Yeah, if not okay, just let me know. Is there any issue in stateful DHCP6 IPDR record? IPDR record. What are you referring on IPDR record? Yeah, maybe you can provide a little bit more details on the question. Then let me stop sharing the slide, and then I will go to the lab interface, and then I will share the lab interface. Okay. As an ISP, you might not assign the IP to each end user, right? You will assign the IP. You will assign the IP to the customer side. I mean, if the customer has 100 users in their LAN, you will not assign to that, but you will just need to record the subnet that you assign. Oh yes, if you mean the prefix delegation, I believe if you are using, for example, if you are using the PPPoE or Radius, you should have the log file for that. It shouldn't be an issue, right? You should be able to know that which user is getting which IP. I mean, at least you know which customer side is getting which prefix. You don't have to assign the IP until the LAN of the user.
For the DRs or record keeping guidelines by the government, you may need to go for DHCP, stateful DHCP, not the stateless. And then collect the logs from your DHCP server. That should give you the MAC address and IP address mapping. If for those cases when you don't need that, just maybe stateless would be easier for you, because stateful means you need to remember or you need to arrange some DHCP Pv6 server with enough memory and enough processes so that it can actually maintain that for long, for actually the whole time. So yeah, for IPDS, use stateful DHCP v6.
Okay, I hope I will answer this question. Yes, as I said, anything that you need to track specifically, then you need to use DHCP, because Slack doesn't track anything. Even the router does not know how many users are there totally in the network if the user is inactive. If the user just simply configure the IP and then the user does not send anything through the network, then the router also cannot know. And the router will not keep track of any user that send the router solicitation message also, unless you are turning on debug and log it. So yeah, if you need to track, then go with DHCP. Okay, so let me share my screen again, and then I will go to the lab. Okay. If you cannot see my screen, let me know about that. And we will go to this lab, Microtech Slack DHCP v6 router lab. I have to say, actually, the feature of the Slack and DHCP v6, especially DHCP v6, is more complete in Cisco and Juniper based on our observation so far, because still there are some features not implemented in Microtech yet. But since when we received the request of this training, the training request clearly mentioned about Microtech. So in this lab, we will go with Microtech. But if you are interested to see other vendors like Cisco or Juniper, both of them are available on APNIC Academy, and then you also can test both of them. Now we will go to the Microtech one, and then I will do the live demo for this. For any of you that would like to participate and then do the lab together, you can log into Academy and then click on the link to launch the lab. Make sure you enable the pop-up on your browser. Otherwise, you will not see the lab window open. Now I will share the lab screen. Can you see my lab screen? It is saying that the virtual machines are starting and it will be ready around 40 seconds later. Okay, thank you. So just wait for it to load. So this is the Microtech Slack DHCP V6 lab, and then you can see this is the lab topology. It is quite simple. We have a router, which is the main part of our configuration, and then we have the switch connecting two hosts. Basically, we will configure the router to enable router advertisement. In part 2 here, we will use the host 1 and host 2 to get the address from the router advertisement, and then configure the address automatically using Slack method. And then part 3, we will do the stateless DHCP v6, because actually, as of the time that we developed this lab, at the time, Microtech did not support the stateful DHCP v6 very well yet. So in our lab here, only have the stateless DHCP v6. But I believe if you are going to the Cisco and Juniper lab, you might see the additional step for that. Okay, so let's go ahead to the lab. In this lab, the first step, we need to do some pre-configuration, because by default, Microtech did not enable IPv6. So we need to go and enable IPv6 on the router. So we log into the router. For the configuration, I believe you can follow the lab instructions step by step, like what I am doing here. And then let me tell you a quick way to type in the command into the router. You can use the copy and paste function here. If there are some commands you would like to quickly type in, especially like IP address, you worry you will type wrongly, then you can use this T to quickly type the command into the console like this. Like I press T, here it is showing the command in the console. And then it is showing that IPv6 is not enabled yet. So we need to enable IPv6. And then the step to enable IPv6 would be system package enable IPv6. Then after that, we need to reboot the router. So I will reboot it now. Along the way, you have any question, you can type into the chat box. Once I see the question and there is a time to answer, I will answer the question. Microtech reboot is quite fast. So now you can see it is rebooted. And then if we print the package again, you will see IPv6 is enabled. Yes, if you want to practice the lab together at the same time that I'm doing live demo, then use the link that Awal provided. Then you can go to the lab. Actually, this lab is available 24/7. And even after the training, also you can try anytime. So if you are not convenient to do it now, you can also do it later. Or if you want to follow me step by step, then can do it together. Then now after we enable the IPv6 package, we should see IPv6 is enabled. We can test to show IPv6 address, you will see one link local address is generated. For IPv6, link local is always there most of the time. So when you enable IPv6, the active interface, you will see link local. And then now we can move to the part 2, configuring Slack. We will still configure on the same router. Basically, we need to add the public IP address to the router. Here we need to add IPv6 address. And then here we need to say advertise equal to yes. Advertise equal to yes means you will send the router advertisement from this router. Because sometimes you might want to configure the IPv6 address to the router, but you don't want the router to... password of the MikroTik is empty. You just hit enter, no need to type anything. Sometimes you might want to configure the router with the IPv6 address, but you don't want this router to be a default gateway for the network. Because when you enable router advertisement, it means other hosts in the network, they will try to configure the address using Slack, using the router advertisement message that this router is advertising. So only configure advertise equal to yes when you use it as a gateway. And then we will add a loopback interface on the router just for the host to test ping. And in MikroTik, the way of adding loopback is to add a bridge and then mention the bridge protocol is none. Then this is adding a loopback, and then we will add an address to the loopback. You can see here, when I add it to the loopback, advertise is null because we don't intend to send any router advertisement on the loopback. It doesn't have any meaning. So that's why router advertisement is null. And then after that, reboot the router. Now the router is rebooted, and then I am logging into the router. And then if we go to IPv6 address print, now we should see, okay, we should see the IPv6 addresses are active on the interface. The one with the G means the global unicast address, and then the one with L are the link local addresses. Then next step, we can go and check whether neighbor discovery is enabled. It should be enabled because when we add the address for the Ether one just now, it is the LAN interface. We add the address, we set router advertisement equal to yes. So now in the neighbor discovery, it is having a record that it will do the router advertisement for this prefix. And then this is the command for seeing the IPv6 routing table. When we add an address to the link, it will create a connected route. And on the router, if we want to see when the client is requesting the router advertisement and then configure the address, we want to see the log file, we can add the debug log. On MikroTik, the way of adding is like the system logging add topics equal to RADVD. RADVD is the router advertisement daemon, and then debug. So it will add this into the log topic, and then it will log when the client is requesting the router advertisement, and then it will log to the memory. It means that when you show the logging, it will show. It will not log to the file when you say action equal to memory. If you say action equal to disk, then it will save to the file. So now after we added this, we will go to the host. I will start from host 1, H1 here. I will see whether H1 can configure IPv6 address. We can open the terminal, and if the text is small, let me enlarge it a little bit, maybe 16. Okay, then if we run the command ifconfig, now you can see there are already IPv6 addresses here, because at the moment when I reboot the router, then maybe when the router rebooted, the host started to configure the IPv6 address based on the router advertisement that the router sent. And then in case if the router did not send the router advertisement, then the host will send the router solicitation. Now I can disable the interface and then I will enable the interface again in order to trigger the debug log on the router. If we are not doing with the graphic user interface, we can also do it with this command sudo ifconfig the interface name down and interface name up, and then the root password is root. I can also do this again. If it is asking for root password, then type the root password, and then I will bring up the interface again. And now I think it is configuring, then wait for a while, it should get the address. Let's go to the router and have a look what happens. Whether anything log, we can go to log, print, and have a look at the log. Yeah, the router received router solicitation and then sending router advertisement. So if we go back to the host, let's see. No. If I disable it using the graphic interface and then re-enabling it, whether this will work. Yes, it works. So let me try with the command. If I shut down it and then I bring it up, yeah, it works. I guess maybe because of just now when I shut down and bring up, I type the two commands too quick. The interval between the two commands is too short, so not completely shut down yet. Then I bring it up again, so that's why it appeared not to work. But now it's okay. Then now let me try again. If I will shut down and then I wait for a while, and then just bring it up again. Yeah, it works. Okay. Yeah, everyone, please do not hesitate to ask questions. Actually, we are very happy that we got a lot of questions during this session, and then we can see everyone is very interested and active. Actually, we are happy to get the question. The only thing just about sometimes that due to the time limitation, we cannot answer all the questions very detailedly. Okay, then now after we configure, actually we can do the same thing for H2. We can do the same configuration for H2 like H1, which is simply just disabling and enabling the interface. Then you will get the address configuration done automatically. It is the same as H1. And then even I think we might not even need to do it. It might be configured already. Yes, it is configured already. So yeah, it is like this. If it is not, then just disable and enable the interface. And then now on H1, I will test to ping to the router's loopback. Yes, it works. So it means that the address assignment, I should say address auto configuration is working, because this one we don't use the DHCP, there is no assignment. That the address auto configuration is working, and then the routing is working also. The routing is working also. That's why it can ping to the loopback address of the router. And now if we go back to the R1, and then we see the log, we should see multiple router solicitation, router advertisement message. Because just now we shut down and then we bring up the interface several times. And then if we print the neighbor, we should see there is one neighbor. This one, which is the host one, it appears on the neighbor list. And finally, if we don't want to debug for this topic anymore, we need to remove it. Otherwise, in production network, if you are doing like this, then your router will log a lot of things in the log file. So I will remove this debug topic by removing the number 4 item of the system login. Yeah, we have done part 2 for the Slack configuration. Then next we move to part 3, which is the stateless DHCP v6. For the stateless DHCP v6, there are 2 ways that we can configure and send the DNS to the client. One way is we need to configure. This is the way in Microtech. In Cisco, there might be some difference in the configuration, but in Microtech, we need to configure the DNS in the router's own configuration, and then after that, we need to configure a DHCP server. Alternatively, if you don't want to configure a DNS in the router, you can also configure as a DNS, the DHCP option. You can configure the DNS server as the DHCP option, and then in the option, the value is the address of the DNS server that you want to give. For example, if you want to give the DNS server 2406.6400:1, then when converted into hexadecimal, it will be like this. Basically, you just write the full IPv6 address and remove the colon and then add 0x here, then it will be the value. And then you need to add it as the DHCP server option like this. And then on your DHCP server, you need to say that we'll give this DHCP option. Both will be okay. This one is you directly assign the address, the DNS server address that you are using on your router. Like in this case, I believe I am using the Cloudflare DNS on the router. Then if I want to directly assign these two DNS server to the client, I just configure it on the router's DNS setting, and then I just enable DHCP server. Otherwise, if I want to configure a specific IP, I can use the DHCP option method like this. You just need to do one, you don't have to do both. I will do the first one. Then after that, here in IPv6 neighbor discovery setting, we need to say that for the host in interface ether1, we will give other configuration, which is the O flag that I mentioned in my presentation. We have M flag, O flag. M flag means the manage configuration. That one will be the stateful, will be everything from DHCP. O flag means only DNS and some specific information from DHCP, while address configuration is still stateless address auto configuration. So in here, I will set it. Basically, for the host from ether1, we will give other configuration. And then we can print and see the status. Yes, we will give other configuration. And then this is the DHCP server that we configured just now. Basically, we don't give any IP. That's why address pool here is static only. We just use this DHCP to give the DNS. And in order to track, we can add the log topic like this, RADBD for seeing the router advertisement, and then DHCP for seeing the DHCP actions. So we will add these two into the lab topic. And then now go back to the host, H1 and H2. Then now I am in H1. What I will do would be simply shut down the interface. And by the way, before I shut down, I will show you on the interface. If you go to the connection, it is already here. I think because of the just now we applied the configuration on the router advertisement. That's why it is already here. Actually, I wanted to show you is we did not have DNS information, and then after we shut down and we bring up the interface, we got the DNS information. But now it automatically got already. So now anyway, I will shut down the interface and bring up the interface. I will shut down and then wait a few seconds. And then I will bring it up. And then if I go to ifconfig, I see it is still getting the address from stateless configuration. And then here I can get DNS. Yeah. So now we have DNS information. Before that, we did not have DNS information. If you see the screenshot of the previous step, the previous part 2, when we configure Slack, we have only address. We don't have DNS. But now, after we configure the DHCP, we have the DNS information, primary and secondary DNS. And then we can test to ping. Connectivity is working because this is pinging to the loopback, and then if it can ping to the loopback, it means that routing is okay, routing is working. Then if we go to router 1 and then we try to see the log file, we should see the log file of the DHCP. Here have a lot of log file, and then because in the console I cannot scroll, so I will use another command to print the log. I will use log print and then brief. Then this one I can scroll it. So you can see in the log file, I will find it and show to you. There is a place you can see it is sending the DHCP message and then including the DNS server. I think here, DHCP. And then it is sending, and then you can see in DHCP, it is saying that the DNS server is this one and this one. So basically, DNS servers are sent in the DHCP message. And then after finishing all the thing, if we would like to remove the debug topic, we can just simply remove topic 4 and 5 that we added earlier. That's it for this lab. As I mentioned, Microtech does not support stateful DHCP very well in the version of lab that we are doing. So we don't have the stateful DHCP v6 in this Microtech lab. But I believe you can do it in the Cisco and Juniper one, which I would say the purpose of the lab would be similar, just the configuration syntax might be different. So feel free to try it. Then you can find out how stateful DHCP works. Okay, so do you have any question for the lab? Any question? I hope everyone is still here. Okay, if you don't have the question yet, then no problem. You can enjoy your time with the lab, or if you finish the lab, I think we can take a short break. Originally, based on our schedule, we will take 30 minutes break, and now we have only around 10 minutes left. So we will take a short break. Then after that, we will be back to another presentation, which will be delivered by Awal. Okay, so thanks everyone for your attention. Any question, feel free to type into the chat box. And see you again soon in 10 minutes.
Okay, are we good to start? Okay, so let me share my screen first quickly. I hope you can see the screen that I just shared. See, is it visible? Akito, can you confirm?
Yes, I can see your screen.
Okay. Suddenly, once I shared, then I actually lost my messages and things like that on WebEx. So maybe I need to see if I stop sharing. Maybe I'll just take the control out of that window and make it a little bigger. Yeah, I can see that now. Yeah, thanks everyone for coming back, and we are sorry that the break has to be squeezed a little bit to adjust with the time. You know, we are trying to cover I think as much content as possible within this very limited amount of time, but I totally understand that there might be more questions that needs more discussion, but please excuse us in this case to adjust our presentations within the time limits. But if you have more detailed question that requires longer discussion, please write us an email, or remember at the beginning, Makito was presenting something called technical assistance. See, if you go to academy.apnic.net, you can actually book some of our colleagues' time there to do one-to-one discussions, and this is for APNIC members. If you are willing to, and these are completely free of cost. No cost involved here. Just saying because you might need detailed discussion. Now this presentation might seem like a not connected to what we have learned so far, but this is one very important part of IPv6 deployment, especially for the mobile network operators. Something called 464 translation, and in short it's called 464 XLAT. Of course the numbers here, 4 means IPv4 and 6 means IPv6. So there are several translations that might happen, and that's why it's a little bit complicated, but I'll try to make it simple for you. And please let me please keep the questions coming if you have once I go with this presentation. So there are two concepts. One is called the tunnel, and that's not translation. That's basically encapsulation. That means one type of packet it will be wrapped with another different header information. That means you are actually passing some information within another header pack. Okay, that's called tunnel or encapsulation. So you probably have heard about some tunneling concepts in IPv4. For example, GRE is a tunneling concept, or maybe IP in IP. So this one is about IPv6 address or packet in IPv4 packaged. So from outside, it looks like IPv4, but inside is IPv6. It could be opposite. The IPv4 packet is inside, but it will be wrapped with IPv6 headers, so that from outside it just looks like an IPv6 packet. When you need it, if you need to transport a protocol that the transport network or the backbone network is actually a different protocol there. So for example, if my backbone is IPv4, but my user is IPv6, and their packet needs to go to an IPv6 destination, but somewhere in the middle there is an island of IPv4. So I need to transport that v6 packet through this v4 island. So what I need to do is, at the entrance, I have to wrap the packet with IPv4 header, so that the routers in this island will think that this is an IPv4 packet. And then once it exits the island, then again everything is normal. So there is no need of this outer package or outer layer. You can just remove that. So these are like tunneling concepts. And in IPv6, these tunneling concepts were more how can I say, the more popular or more in the discussion at the beginning of IPv6, because that time many networks had devices, routers that are not IPv6 ready. So they needed the tunneling for that. But the more the network operators buy new equipment, these routers nowadays understand both address families. So the tunneling is not very popular anymore, but still there are some use cases. Translation, which is the topic of my session now, is about not adding a new header, instead changing the address itself. That means translating the address information within the same header. So that's called translation. And there could be traditionally for IPv4 NAT, or network address translation, we call it NAT44, because it's taking a v4 address, translating into another v4 address. So that's why NAT44 or NAT44. But when we talk about IPv6 and IPv4, then comes NAT64 or NAT64 or NAT46, and then there could be other types. For example, if you take a v4 address, translate into v6 address, translate back to v4 address, that's 464 translation. So basically, we encourage people to start with dual stack deployment, because this is the most simple, easy to maintain, easy to start with IPv6 deployment. So the dual stack means you are running both protocol stacks, and your routers, your ISP, your customers, if they're okay with running both address families, you can actually give them both address families and service to the both address families to the customers. So in this diagram on the right side, as you can see, let me see if I can get a pointer icon here. Yeah. So on the right side, as you can see, my computer here, I'm a customer of my ISP. My computer here understands both V4 and V6. That means my device is dual stack, and my ISP gives me IPv6 address as well as IPv4 address. So what will happen is basically I can reach to any IPv4 destination using my V4 address and any V6 destinations using my V6 address. So it's like a native communication for both address families. I'm not translating anything. I don't need to go to V6 address destinations using my V4 address. I don't need that because I have V6 address. So what are the advantages and disadvantages? Of course, this is simple, this is easy, and this is cost effective because you don't need to buy big IPv4 net box. Okay, if you are a telco, you are probably using millions of net sessions. So those are expensive equipment. I can see a question here from Dika. What about in IPv6 prefixes a blacklist in public spam service? So in order to fight with spamming, you need to do filtering based on the SMTP ports, and then also encourage your customers to follow the practices of using the emails and browsing and things like that, not being affected by the spam packets or malwares. You can definitely configure very strict policies for your customers and can block packets that can possibly cause your prefix to be blacklisted. Now, you are still getting those blacklisting for your IPv4 address. Similar thing can happen for your V6 address. No other separate actions needs to be taken for V4 or V6. Whatever policies you have, you will just replicate this for IPv6. So with this dual stack solution, what challenge you have that you cannot skip IPv4. You still need IPv4, but really not to many destinations. I am just predicting it. This number is, there's no like exact number to me, but I believe more than 90% of the internet contents are now available over V6. So only for less than 10% of the packets or volume of data that an ISP deals with probably have a V4 requirement. So your V4 address requirement becomes very less if you are dual stack. Majority of your traffic is going to take IPv6. Very minor amount of content or data might follow the IPv4 path, and that means your NAT is not that heavy anymore, and your V4 address requirement will be reduced, but still you need V4 address. This is a side slides, so I'll just briefly cover that. The happy eyeball says that if I have dual stack, then my computer will try to resolve a domain using DNS to look for whether that destination or that domain has V6 entry, which is called quad A. And if the resolution is done and I get quad A, my device is going to try and start the session with the V6, because I can do both. So I'll just look for V6 first, and then if the domain doesn't have a quad A record in their name service, it will then try for A records. And for example, if I get the answer and my device is still trying to start the V6 session, after waiting for some time, once the session is timed out and I don't get the connection, I will start V4. So it's like I have both options, but I'm trying to give V6 a little bit more preference. But of course, whichever is better, the device is gonna start session with that. But my main concern is with this diagram, and I need everybody to understand this. And there are some similar diagrams, so I need really your concentration here. The other materials is easy to understand. You can just read later by yourself. But this one is might require your concentration a little bit. So you see, this is my computer or my mobile phone, whichever you may think. So let's say this device is IPv6 only. For this example, just think about it. This is an IPv6 only device, and my backbone is also IPv6 only. So for my backbone, I don't have IPv4. For my customers, I am not giving them any v4 address. I'm only giving them v6. Okay, so almost all the manufacturer, the mobile phone and the computers and the tablets, the operating system supports something called client translator, or CLAT. And on the right side, the provider's gateway has something called provider translator, PLAT. And what happens with this mobile phone is that, let's say it has a v6 address, but it, of course, if it wants to go to the v6 destination, because the mobile phone has v6, the backbone is v6, and the destination is v6, of course, that's a native v6 communication. No translation is required. But if this device wants to access a IPv4 only destination, for example, github.com is a v4 only. Unfortunately, the GitHub is one of the largest repo for technical projects, but unfortunately I haven't recently checked, but they probably are not yet v6 v4 only. But anyway, so let's say I'm gonna browse github.com. What will happen is my operating system has a built-in translator. Okay, so it's basically will distribute me with some private address first internally. Internally is going to give me a v4 address. So this device has a CLAT package that is going to give a v4 local, completely local within the device, completely local private IPv4 address. And then when the session starts, the CLAT will basically translate this address to IPv6 address, pass it through the backbone, and comes to the gateway or provider translator. It doesn't have to be the border router. It can be somewhere in the middle, as long as it has one hand towards the internet, IPv4 internet, and the other hand towards the backbone. It's okay. So let's say this PLAT, once it receives the packet, that's a v6 packet, it will actually change both the source and the destination address to IPv4. So GitHub server, here's just an example for GitHub. I should generalize this. Let's say this is a v4 only server. It will just think that, okay, I'm talking to a v4 customer or requester, right? Client. It will not understand that there had been like twice the translation has happened. So basically, this customer end device is having something called stateless NAT64, and the provider router or the provider translator, it's having a stateful NAT64. Why it's stateless and the other one is stateful? Because this customer doesn't need to remember any different IPs. It's just a one-to-one, because it has only one public IP, only one IPv6 address and one IPv4 address. So it just only remember the session. That's it. So it goes out. Of course, it will take that particular IPv6 address. Once it comes in, of course, it will transfer back to the same IP address. So that's why it doesn't need to remember any state. But for this provider router, it might be serving many customers. So that's why definitely needs to remember. It's similar to IPv4 NAT. So it remembers the NAT translation information in the database. Before going further, let me check the chat window. There had been some questions already. Where should I start from? After the community trainers mailing list, blacklist. What about V6 prefixes in public spam? I have answered that. So Jayesh asked a question: why IPv6 DNS resolve are preferred over IPv4 DNS in Windows? So this is called happy eyeball. That has been accepted by almost all the operating systems. So they will try to figure out whether there is any quad A record first. And if you want to ask why, that's just a preference set by the community or set by the operating systems. They want to find out if they have a V6 entry in the name server for that certain domain. Of course, you need to have V6 in your device. The courier needs to have V6 in their device. If you don't have, then it's not going to do that. So it's for the dual stack or IPv6 only customers. Oh, sorry, Makito, you have already almost answered this. Sorry for that. So yeah, no other questions. Sorry. Yeah, so let's go to this this middle part here, the embedded IPv4 embedded IPv6 address. So this is basically you reserve a V6 subnet and keep space for V4 address to embed in this V6 address. So what I'm saying is something like this. Let's say I have an IPv4 V6 address. I have an IPv6 subnet 64:ff9b:/96. That means I have 32-bit remains for the host bit, right? Or the interface ID, whatever you call it. So I can actually put an IPv4 address here to make it a 128-bit address, which will look like a V6 address. That means that's called IPv4 embedded IPv6 address. And this is well supported. And you can still use the dot within the IPv6 address. So I'm going to show you something. So this is the RFC 6052 that actually refers to the IPv4 embedded IPv6 subnet. So you can start from 32 to 96. Usually people use 96 because that means you can use a 32-bit address here. So here is the CLAT summary. I have already covered some of the concept here, but let's look at the diagram to understand. So I already said that the CLAT is stateless, so it's just a one-to-one mapping. It doesn't need to remember those states. It will just change the address because it has only one address for V4 and one address for V6. And for the embedded address, let's say this is my /96 prefix, and then I have the V6 and V4 address to embed here. So how we do that? First, my PC, once my PC wants to talk to a destination server, is going to look at, if it is a domain name, it's going to look at the quad A, which is the V6 resource record for a domain. And then if the record exists, it will just take it and then start a V6 native communication, because that's a V6 and I have V6, so I can just do a V6 communication. But if it has a record, then it needs to synthesize it to make it look like an IPv6 address. And that's gonna be done by DNS64 or DNS64. It's simple to configure in your DNS server. You just need to mention that this is my prefix to convert any V4 address into V6 address, right? So, and I'll show you in this diagram as well, so how it works. So let's say this is my PC. My PC has a DNS, so it is gonna query that DNS resolver for a quad A record for test.com. Why it's asking quad A record? Because my computer understands quad A, so it looks for quad A. Now DNS 6.4, this is the resolver. It's you know, how the DNS works based on this standard procedure is gonna talk to the root and things like that, and finally root TLD and to some certain domain. Let's say test.com's authoritative domain name server. It asks for quad A. Let's say it's replying with saying that I don't have any quad A for this because this server only understands v4. So it's gonna ask A record now, and then this time the answer comes with a v4 address. Now the DNS 6.4 is in a situation where the customer is my PC. It's asking for quad A, but it has a response from the authoritative name server, which is A. Now this DNS 6.4, this is going to synthesize or actually, you know, change the address into a v6 address and then pass it to the customer. So customer doesn't understand what's happening out there, right? So it's just gonna send the response, just adding the v4 equivalent hexadecimal digits here. So how many digits, how many bits are here? 16 and 16, 32. So this 32 basically equivalent to this IPv4 address. So if you convert this IPv4 address into hexadecimal, you will see something like this. And because this prefix is defined by the network admin, that whenever there is a translation required, you will use this prefix and just add the v4 equivalent hexadecimal number at the last part of this prefix and then just answer to the query. So this answer comes to my computer, and my computer now can talk to the IPv4 only destination using v6 address. How it's gonna work? So before going to the translation part, how you configure this DNS 6.4 to do this task. So this is an example for bind. Bind 9 supports DNS 6.4, and bind is the most popular open source DNS software package. So you can just add this configuration in bind, which starts with DNS 6.4, and then you mention what is your prefix, and then the size of the prefix is 96. That means you have 32-bit to be able to put here. And then you can say some optional value configurations. For example, what type of IPs you want to support. Is it your customer's IP, or it's only some certain IP, or everybody? And then what are the IPs that you want to map, and then whether any IPs that you want to exclude, even if it comes as a response, you don't want to serve them. For example, this is an invalid address, this is a reserved address, you don't want to serve them, something like this. And break DNS, you have to put yes, because if you change the IP, that's similar to a man-in-the-middle kind of attack, right? Similar to this in terms of DNS 6.4, in terms of DNS security or DNSSEC. So in that case, you have to say that I'm okay if the DNSSEC validation fails. So you have to say that expect the DNSSEC fail. So you need to mention yes. These are the explanation of what I just mentioned. Now, provider side is an stateful 6.4, and because it's N-to-1 mapping, because provider is going to support many of these type of customers. So what's going to happen is the same prefix you have to mention in the NAT what you mentioned in your DNS server, because the DNS synthesizes the v4 address looks like an IPv6 address that needs to be similar to your network address translation or NAT box, because then it will understand, okay, since I see you use that prefix, that means the last 32-bit is the IPv4 address. So I don't need to bother about it. I will just take those 32-bit and convert it into v4 address. So I can just, pass the packet to the v4 destinations. So this way it will understand. If you use different subnets, then it will not understand, right? So now here is the complete picture. So here Again, same example. Let's say this is my computer or my laptop or my router, whatever. It has the CLAT software. So let's say my source address is a v6 address. My destination address actually is a v4 address. Remember, my destination is a v4 address, but previously when I requested my DNS64, it actually changed that IPv4 address and gave me a v6 address. So my device unknowingly actually trying to talk to a v6 destination. So what is going to happen? The packet will come to the PLAT, and the PLAT will use a v4 pool to NAT my IP, which is this source IP. This is gonna be my public IPv4 address, and that's coming from a public pool configured in this router. It's similar to a NAT. So this range, it's taking the first IP as my source IP, and this is the port number. The destination IP is actually the last 32 bits. So it's converting it into the actual v4 address and then send the packet to test.com. Test.com send the v4 reply. PLAT has this state, right? In its memory, in its NAT table, it will change it back to its v6 source address and destination address, and then pass the reply to the device or the customer. The customer device will be happy to see that it will understand that it's talking to the IPv6 destination. Actually, no. So the stateless part here is for the CLAT. CLAT doesn't need the stateful information. Now here, let's say this is different than the previous example, a little bit different here. Let's say this time I don't want to pretend that I have IPv6 address, the destination has IPv4. I don't want that. I want to talk to the v4 destination using my v4 address, but I don't have v4 address. Destination has v4 address. Previously, I was translating the destination's address into v6 and kept my v6 address as it is. But this time I'm going to do something different. There are several applications. Maybe previously Skype was one of the examples. I'm not so sure if Skype now understands v6, but Skype previously has these issues that you need to be v4 to talk to a Skype service, something like this. So in those cases, what your CLAT is going to do is it will create a v4 local address and give the application. So the application now will understand that myself, I'm a v4 host. I'm not a v6 only host. I'm a v4 host. So your v4 address, let's say in a random manner, let's say this is your v4 address given by your CLAT, and your destination this time, this is not a pretended, this is not a synthesized v6 address. This is actual v4 address. This is the server's IP. So now I'm generating this, but as soon as the packet pass the device, just before that, the CLAT actually gonna translate it into v6 address. So the application itself doesn't know. It still sees its own address as v4 address, but the device CLAT package or software is gonna translate it before sending it out to the device. So now this time my source and destination is going to be something like this. The source address, I have a prefix. This is my prefix for source address, and this is my prefix for destination address translation. So the source address is going to be this 32-bit coming from my source IP. This destination IP is 32-bit coming from my destination v4 IP. So both of the addresses got translated. This will travel through the backbone to the PLAT, and the PLAT has the v4 pool. So it's gonna translate the destination with the original destination address and source with a public IPv4 address. Now this one is gonna communicate with the v4 server. Once the return packet comes, it's gonna change it to the based on that NAT table, because it keeps the states, and then it will send it to the customer. The customer CLAT is going to change it back to its application's own IP, and then serve the application. There are some open testing tools. If you configure NAT64 DNS64, you can test your setup here on this Go6 Lab NAT64 DNS64 tester. Mobile devices have been supporting this CLAT or 464 translator, Android since 4.4, which is KitKat, and IPv6 supported by iOS 9. I think since maybe almost both of them since maybe almost 10 years already. And then in 2016, Apple said that all its app store the apps has to be IPv6 only, or needs to support IPv6 only as well. So this DHCP v6 prefix delegation, it's supported since 3GPP release 10, which is basically the standardization body, the third generation partnership project. This is the standardization body for the mobile standards. I think as we'll find from RFC 70 to 78, you'll see that mobile devices can. So there are two different things. One is the prefix delegation. So if I'm a mobile user, I connect to my mobile network, they will give me a v6 address, and if they can give me prefix delegation PD subnet, that means I can give it, if I do tethering, I can give it to my users because I'm now a router for them, right? So I can give that prefix to them. But for if you see RFC 70 to 78, it says that even if my telecom or my ISP giving me v6 address, my device should be able to use the same prefix for the other customers when it's doing the tethering. So both are supported. For the CPEs, you probably need to look at your vendor's documentation when you buy the home routers, the CPEs, the dongles. Please take a look at this specification, whether it can support v6 IPv6 only with the 464 or CLAT with the CLAT support. So this is pretty much it, but I think I would probably be able to show you the lab, and then if time permits, then I'm gonna cover the second slide deck. So let me share my screen. That's gonna be for the NAT64 DNS64 lab along with the CLAT. Here's the slide deck. Okay. I think you were still looking at my shared screen here, so it should be if you go to the event page one more time, this is the NAT64 DNS64 session. So if I click here, you'll see that it's gonna take me to our academy lab, and similar to what why I'm here, let's say this one. Yeah, so you should be on our virtual lab platform, and then the first lab you will see is the stateful NAT64 DNS. I'm just clicking on launch lab. It should open a new window, and you should be able to see that as well. Let me see. It might take about a minute to launch. Let me see if we have any questions. So just a quick reminder, if you see our chat window, Makita has shared our survey link. So please participate in the survey. You can share your opinion there, how the training went, and what are the other topics you may want to get from us, and whether there is any suggestion, any comment, any observation, please feel free to share. One issue we face for like a short tutorial is that participants seem like they want more time. So we understand that, and probably NICSI and our other trainings that we cover in the region probably will have more time in future to cover some of the contents in detail. So this one had a couple of parts, as you can see on the right side. It has part 1, which is v6 only host configuration, then v4 only host configuration. Then there is a stateful NAT64 DNS64 configuration along with DNS, first NAT64, then DNS64 configuration, and then we'll have CLAT as well. So this is a simple, very, very simple diagram here, topology. It's the minimum setup to give you an understanding or a sense of what the NAT64 and DNS64 does. So here I have a v6 only, v4 only host on the left side. On the right side, v6 only client, and they want to communicate. That's the main task. They want to communicate. Now the problem is they cannot communicate because both address the two different address families, they don't understand each other because of the header format. Their headers are completely different, right? Now I need to have somebody here who will help me with changing the A records or DNS records. If it is v4, then v6, and then if my packet, real packet, goes to a v4 destination, but I'm v6 only, then somebody needs to translate it as well. So everything is here, both NAT and the DNS 6.4 translation is going to happen here. But in your real life, this can be in different devices. Can be located to different locations. No problem with that. Okay. Now let's see. First, we'll start with v6 only client. Okay. If I click on this link, hyperlink, okay. So this is my v6 only host. You can tell just looking at this. Now this is my terminal. It looks like the terminal icon is not okay because the host is not yet fully ready probably. But anyway, I can open the terminal from here as well. Is it here? It's probably still loading. Yeah. Now it's okay. So I hope the font size is okay for you to understand. See on the chat window if anybody has any. Okay. So first thing is, let's configure its interface. Remember, it has only one interface to the intermediary DNS64 NAT64 box. So first, I'm gonna check the interface config. So for that, I'll just do this. So this is a Linux server. That means the interface configuration will be, and because this is not NetPlan, this is not a NetPlan, or this is not the latest version of the Linux one. We are using the older one, and then that means it is in the directory etc network, and then the file is interfaces. And if I go there, the username is APNIC, the password is training. So if you see that I have this configuration for my interface ENS32, and it is DHCP, but I actually need to configure with this like static IPv6 address here. So my address will be :100, and then my subnet size is /64, and my gateway is :1 because that's my other device on the other side. That's my gateway. The gateway basically here is the NAT64 DNS64 box, and then this is my DNS and my domain. So somebody mentioned earlier during our first half of the session that they were trying to configure the Linux machine with IPv6 address, but is not successful, or maybe not being able to communicate with the with their gateway. So here is a simple configuration. So let's see, if I click on the T means copy and paste. So I'm going to copy and paste it on the right side just to make sure if my commands are okay. It looks like okay. So let's save it. So to save, Control X, Y, and then yes means enter is to accept it. Now I have to restart my network to apply the config. Let's see if my config is so if config it's not applied yet. So here is something mentioned that if your server doesn't reflect the IPs, just reboot the server. So I'm gonna reboot that. And once rebooted, I'll check back, but let's go to the next lab because it's gonna take some time to reboot. So this one is v4 only host, okay? So this v4 only host, similar to the previous one, I'm gonna just configure v4 address, not v6 address, okay? So similar thing, I'm gonna go to this interface configuration and remove its DHCP part. And then let's just copy and paste the IPv4 information. There are different ways to configure IPv4 IP addresses on a Linux interface. So this is just a kind of a easy and a simple version here. So what I'm saying that this is going to be a static IP and my IP will be this one. My subnet is this. My network is this. So you probably don't need to put those in detail here. Sometimes it's just /24 should understand what is the mask and network and things like that and broadcast. No need to put all these details, but in our lab we just want to keep it because there are many different types of users and this is online lab. They cannot ask us questions. They need to understand by themselves. So we try to put as many information as possible, as much information as possible to help them understand by themselves. So now let's save it. Similar thing. And I also again need to reboot that. But before that, because this is a device that needs a domain name, because I want it to locally have a domain resolution here. So let's just put it on the first let's change the host name for this one. This one has been mentioned at the beginning of the lab is v4 only. What I'm gonna do is I'm gonna make its host name as group1.apnictraining.net because we are gonna use a browser to browse this this domain, okay? So that it will find this domain. That's why we are doing this. And then locally for this host, it needs to resolve itself. So we are just going to create a host file where I'll just put, instead of this v4 only, I'll just put its recent name that we have given. That's group1. Oh, sorry. And then also for its own IP 192.168.30.254 group1.apnictraining.net. And you know this information actually is mentioned here on the screenshot. So once I finish this, let's save it as well. Now, because this is IPv4 only host, I need to disable IPv6 routing and IPv6 services because by default on a Linux machine, it by default enables the v6 packages and services. So what I'm gonna do is under the system control config file, there are some of the settings which is by default I think enabled. So we need to find those and actually disable them. The other thing what we can do is instead of finding and replacing, what I'm gonna do, let me see actually whether they exist or not. Actually this is disabled already, So because the default behavior like that, I'll just put it here at the end of this. Okay, so it's already there. It's already there, as you can see here. IPv6 all disabled, yes. 1 means yes. And then you also disable IPv6 config for the default configuration and I think the look back as well. So since that's there, I don't need to change anything. That's done. And now probably I also need to reboot the server, and then because this is gonna be my destination, and I probably need to test a web server access. So this has a HTTP server already running here, which is an Apache. We'll just see after the reboot, we'll see that this Apache server is running to test from our v6 only host. This one is v4 only server, and my v6 only host needs to talk to this v4 only server. Just before going there, let's go to v6 only host again to see whether my IP address has been applied. In real servers, this is a virtual lab. In real servers, if you just restart the networking on interface, it should just get the new IPs. So here, you don't need to reboot your server in your real network. That's what I'm trying to say. If config should give me now my IPv6 addresses, yes, my IPv6 address is 100 and there is no IPv4 address. So that's what I wanted from my IPv6 host. From my IPv4 host, I wanted the opposite. So let's see, from my IPv4 host, I wanted to see whether it has just IPv4 address, no IPv6 address. So as you can see, I have this IPv4 address here, 30.254, and I don't have any IPv6 address. Okay. Let's see if my Apache server is running. So I'm just gonna check the status of my Apache server. It's actually running. So this is a pre-configured Apache server. So that we can test a website access, right? So before going there, just to see whether my server has a HTML file that I can access or not. If I go there, yes, I can see that the HTML file, it's a simple one that says IPv4 only page. So when I browse that server, I should see that exact information on my browser from the server, right? And actually I can browse myself from this device. Let's minimize and try to open the browser. Should be here somewhere. Yeah, this one. So I'm gonna browse myself. So http:// and then I can have localhost. Yes, that's one. I can actually use my own IP as well. And if you want, you can actually check it from here. Netstat. So you see this HTTP is running and it's in listen mode. Anyway, so this is okay, but this is an IPv4 only server. So my other device, which is IPv6, should not be able to browse that, right? So because it doesn't have the v4 understanding yet. So now the middle device, the middle one is the translator and the DNS6 port. So I'm going to go to this device. This device should have both v4 and v6 addresses, right? So first let's log in, APNIC, and training is the password. So if I try to configure similar way, so first let's check how many interfaces I have. The other two devices have only one interface. This one should have two. So you see ENS 160 and ENS 192. So I'll make one as v4 and the other one as v6, because let me take you to the previous pages. So here you see I had configured the v4 only server. the v6 only client, but this one has two interfaces. One should be towards v4 only, the other one should be towards v6 only. So that's why I need two. So yeah, so let's configure the first one. Okay, the first interface will be the ENS60, and for that I will just do this. Okay, so this one is need to comment them out. Okay, let me just comment this out first. I don't need them. These are like automatic configs. What I'll do is I'll just add this first set of commands. That's v4 only. Remember, I put gateway.1. This is .1, and then I also will put the IPv6 addresses as well here for ENS192, and this one is just 1 and /64. Okay, so once this is done, Control X, Y, and then enter. So this should have my configuration done. And again, this one needs both. This one needs the routing enabled, the IPv6 routing and IPv4 routing enabled. For IPv4, we have disabled those, but for IPv6, I need them. That's why I have to go and check whether they're already there or not. If I see this is the config here, this line, I had this commented out, right? So what I want to do is I want to enable them, and then the IPv6 one should be here. Yeah, this one. So both of them are activated. Again, I need to save it. Done. Now restart. I think it's not gonna work, so let's reboot quickly. Then once this is again up, I will see I should be able to ping my v4 only servers on one side, should be successful. v6 only client on the other side should also be successful, because I understand both, right? So this server understand both. So first, this is my PC. So this is my server, v4 only server, and it is successful. It can reach there. Let me ping with ping6 command, and the IP is 2406.6400, and then ::100 is my, yes. So both of them are reachable, but now I need to turn my NAT64 server on. And now for the Linux, there is an open source tool called Zool. The Zool is installed here, and it's very easy to install. If you search like install Zool, you'll see very simple documentation to do that. And I have to enable some modules and mention that this is my v6 pool. And why I need the pool, remember I explained you need to have an embedded v4 embedded v6 address, and that's why you have to declare the pool of which pool the v4 address will be added to. And this has to be same for the DNS64 and for the NAT64, so that they understand each other, right? So I'm gonna add this first. The password is training, yes. Then this second line, as you can see here, is basically configuring the v4 pool. So this is the v6, and this second line is saying that my NAT will be using this IP, and the port range is from 9,000 to 10,000. Actually, you can make it to all the way to 65,000. Yeah, all the ports are available for the use. So I'm using Zool to say that if you want to do the v4 translation, use this IP, and the port number range is like that. Now to check my v4 ports, you see here, I can use this IP for TCP, UDP, and ICMP, and the port range that I mentioned. For the V6 one, you can just see my V6 subnet is this one. And then since everything looks good, I'll just enable Zool. That means I'll enable NAT64. So I'm configuring Zool enable. And just to check the status at the moment, you see that this has, so I'm gonna lose some of the output because I cannot scroll back now. So it's like the status is enabled and it has several prefixes and ports already ready for this. Now if I ping, now this one is interesting. As you can see, I'm gonna ping from my V6 host. So let's go to the V6 host, because now the NAT64 is ready, but DNS64 is not yet ready. So I cannot do DNS resolution, but I can do NAT. And so for that, what I'm gonna do, I'm on V6 only host. I would like to ping, but remember I'm talking to a V4 destination. But because I'm V6 only, I'm using ping 6, and my prefix is 2406 colon 6400 colon 64 colon 64 colon 64 colon 64. That was reserved, and then colon, I want to add the destination V4 address 192.168.30.254. Okay, and this is now successful, right? And why this is successful? Because my DNS64 is configured with that prefix. Sorry, not DNS64, NAT64 is configured with that prefix. As soon as it receives, so you see how I'm trying to ping, this first couple of bits, 96 bits are like that, and this is exactly same configured on the middle box, which is NAT64. So as soon as it gets the packet, it removes the first 96 bits. Just look at the IPv4 address and trying to reach the IPv4 address, because that is a NAT64. It has the reachability with v4 as well. It can send it to them, and then once the return packet comes, it has the stateful NAT information, so it will translate back to my address and then pass it to me. To see that whether that has a translation table, you can just try to check it. This is binding information base, or BIB, and if you click and password training, oops, sorry, I think the latest version just removed it, isn't it? Oh, sorry, I cannot use this command here. I need to check the translation on the NAT box, not on the user PC. The translation happens on the NAT box. So let's go and see this command. Yeah. Oh, I have to ping it again because it's just cleared its table. So let's go to the V6 and try keep this command running. And then let's go to the NAT64 box. Same command. Yes, you see that my PC's IP 100 is trying to reach a v4 address, so it has been translated to the first IP, which is the interface IP of this router of this NAT box. So it's basically keeping the translation in the table. Let's go to v6 only and stop the ping command. Yes. Now let's go to the interesting part. Okay. If I try to ping 192.168.30.254, I cannot ping. If I use a synthesized ping 6 command, I can ping. If I try to ping 6 group 1 dot APNICIRINN.net, I cannot ping because my DNS64 is not ready yet, right? So if I go to the browser and try to, browse, let's say :2406/24:64:64:64 and then :192.168.30.254. That's the server's IP address. And then if I use this, the square bracket, because this is an IPv6 address, I need to use the square bracket and then hit enter. I can browse the page. But that's remember, this IP now changed to a hexadecimal number. That's what I was saying in my presentation, and I hope this is now making a little bit more sense to the topic for you, and it is now meaningful to the audience. So this time I can browse, but the problem is, who is going to browse like this? No one is going to browse like this. Everybody will browse with a domain name, and I cannot resolve the domain name without the help of the DNS64. And the DNS64 will do the exactly same thing what I manually did, right? So let's prepare the DNS64, okay? And for that, that's my next task, configuring the DNS64. Let's go to my NAT64 DNS64 box again. My NAT64 is ready, and that's why I can use IP to communicate, but not the domain name. Now let's see my DNS. The bind should be running. Yeah, bind is running, right? Let's see, and you can see that, right? Bind is up and running. And then go to the and check the status. It's active, running. Let's see. I should be able to see my directories and databases here, which is a pre-configured DNS files. So let's go to cd/etc and then bind. And if you see the files here, there are some zones that has been already created, like 192.168.30. And then for the DNS, for IPv6, there are some already databases or zone files are already created. Now, if I go to the options or the config options for the bind, I should be able to see this configuration, which has directory information, recursion options, and DNSSEC. What we have learned from the presentation that I need to disable the DNSSEC, right? I also need to enable IPv6 here. So it's already done on the last line. And then I'll do the DNSSEC validation yes under these options, DNS64, and this has to go here. So as you can see in the screenshot, this has to go after this line, because that's an option as well. So I'm gonna keep the last closing bracket here. You can see the curly bracket that starts from the beginning of this option. So I cannot put anything out of this. So I need to have this command. I just copy and pasted it here. As you can see, the prefix here is same. I have to keep it same, otherwise they will not work in conjunction with each other, okay? And the DNSSEC value break has been set to yes. Now let's just keep it like that and then restart the bind so it works with these additional configurations. Let's check the status one more time. Oops, sorry. What's going on? Oh, so there is a extra character here. Okay, so it's running, should be fine. Now, if I go to my v6 only host, because my DNS 64 is also ready, if I go to my v6 only device, you will see the changes is gonna happen now. Remember, just now I was trying to ping group 1 and it was failing. Now this is coming with a result, right? So what's going to happen is I don't need to write this anymore. I can just say group 1 apnictraining.net, and then the page comes. So this whole translation as well as the domain name resolution is happening in NAT64 and DNS64. And like I said, it doesn't have to be in the same box. You can just put it in different places, no problem. You just need to check whether they can work together and understand each other. The last one is CLAT. What I'm gonna do this time is, remember previously for the v6 only host, whenever I was trying to ping, I need to ping with the IPv6 synthesized IPv6 address here. So I have to have the embedded address. If I ping IPv4 only, it doesn't give me any answer, right? It doesn't give me anything. But I want my software here, ping, for example, is a software here, for the sake of this logic, okay? This is a software that wants to talk to natively to an IPv4 address, but my device is IPv6 only. How come a software inside the device can use a v4 address, talk to a v4 destination natively? It's not going to be able to. That's why I need somebody sitting inside the device, faking the whole communication, trying to pretend that you are actually talking to a v4 address. So that's why there is a Linux package called CLAT-D or CLAT-daemon. We have installed the CLAT-daemon here. What we are going to do is we are going to go to the CLAT-daemon directory. And then I'm just going to make the install and then do the installation. So build the files for installation, and then let's make install. So I think the compilation and the installation is done. Just let's start the service. Should be running, yes. And then since it is running, I can go and check my previous commands. Remember, I was trying to ping this, right? And it was failing. Now let's see what happens. It's successful. How come it's a v6 only host? How come it understands a v4 address? So there is this CLAT-daemon sitting in this device that's taking care of it, right? So that is the end of the lab. So can I see if there is any question? Let me attend those if there is any. In the video, we are going to do some. Sorry. Okay. Yeah. We can do. I think we cannot send you any email from our side, but it's so easy. You just need to check our event page, and you can just easily download all the materials from there. And these labs are online lab. You don't need to actually worry about it. You can do this lab anytime. Not only this lab, we have many labs on different topics. So just feel free to check and practice any of the labs. These are all free to everyone. Since I have very close to 12 minutes, let me try and see if I can run my second presentation quickly and try to cover that. Let me see. Probably I'll be able to do that very quickly. This is about security, IPv6 security, and you might be very interested about this. Let's see. So I'm gonna, because time is limited, I'm gonna cover like a high level overview, but there is a similarity. There are several places where you'll find similarity with v4. So some contents are new, but some are actually known to you already. So this is an extension header related issue. Remember that we can extend header in IPv6. Why we need header extension? Because IPv4 has the variable header. So you can actually extend the header itself. But in IPv6, the header is fixed, 40-byte header. You cannot extend the header itself. You can take space from payload to extend your header. But in IPv4, it was dynamic. It was flexible. It was like a not fixed. That means you can extend the header itself. So for more functionality, to add more functionality to IPv6, the header has been fixed, but you can have more header, which is called extension header, and Makito covered this in detail. So let's say I have extension headers. So this space is taken from payload, right? Now let's say my packet, the first packet is, let's say, 1500 byte, just for the sake of argument. And I'm an attacker. I'm adding a lot of next header, a lot of extension headers. I don't really have an intention to put any meaningful payload. I have an intention to just put extension header. Why? Because I want the target device to process those extension header and just be busy with that. And I'll send, let's say, a couple of 100,000 of packets to the same device. And it's just gonna be very, very busy with just looking at the next header, process it, next header, process it for several thousand of packets. And that means it's a DDoS attack attempt, right? That means I want that device, the target device, to be exhausted with its resources. That's a problem. Okay, let's see if we have, I think there is a question on the chat window. So IPv6 payload plus header is more when compared to IPv4 payload plus header. No, not really. So yeah, let me explain quickly, very quickly. You have header and then you have payload, right? So altogether it's like 1500 bytes, right? There are like other header options for L2 and tunnels and things like that. But just for the very simple way of understanding, header, payload, let's say altogether 1500 byte. Now you can extend your IPv4 header itself because it's variable, it's not fixed, but it is 20 byte variable header, right? You have options. Remember, in IPv4 you have options field where you can add more options. That means it's going to be bigger. You are not taking a space from payload. For IPv6, the first header is fixed. That's like 40 byte. It's double of IPv4 header, but it's fixed. When you need more option to add, you are actually taking a space from the payload, right? But you are putting a pointer to the main header that this is not the end. Go and check the payload. The first couple of packets, the first couple of information is actually header, not payload. Just process that. You will find what I want you to do, something like this, right? So the main packet size is same. It's 1500 bytes. Okay. If so, packet fragmentation can cause some issue. Hey, of course, yeah, you are right. Packet fragmentation is going to cause some issue, and that is where the attackers are, trying to use to exploit some of the vulnerabilities. But we'll cover, and then you will probably get more ideas. So I'm not going to go detailed. So these are some headers extensions. So 0 and 43 already deprecated. These two are not used, and you have to disable them. That's a security practice. So what comes in here with the problem in terms of these extension headers, I'm going to skip because these are written, so you can just take a look at it. What is the problem? Problem is you can put many headers, extension headers, and also you can actually carry unwanted information in the extension headers. So these are the two things. So let's see what can happen. So this is like, so first one is like my extension header has pointer to an extension header that's basically carrying some hidden data. So that's like command and control servers communicating with the affected devices, things like that. So this is one problem. So the recommendation is drop any unknown extension header. If your device doesn't have a knowledge of the well-defined extension header values, then just drop it, because this might have a possible unwanted packets. All the well-known defined extension headers are already implemented. So yeah, and that means you have to inspect extension header, right? So inspection is very important. But if your device cannot do inspection, then you might need to look into other options as well. Now, unlimited header, like I said, you can put so many headers and can keep your destination node busy just processing that. So basically a DDoS attack. So the recommendation here by the RFC is that doesn't matter how many extension header you want to add, everything has to be in the first packet. You cannot fragment and put more headers to like a seemingly unlimited number of headers, and then device is just gonna wait for the next packet, because fragment packets are not processed one by one. It will wait for all the packets come together and then basically rebuild the original packet. So this is a problem, and the recommendation and already implemented by all the vendors is that everything has to be in the first packet. So your IP header, extension header, and TCP header has to be in the same first packet. That means you don't have unlimited number of options here. So how you should do it? You should basically for the fragmentation, like the question came, for the fragmentation, you should drop fragments selectively. You cannot drop like all, because DNSSEC, when it sends you replies with the signatures, with the additional information, that packet may be bigger, and then including IPv6 is going to be more, then it may need fragmentation. But if you block that, the DNSSEC will break. That's the problem. So instead, what you can do is you can inspect and drop any packet that doesn't have transport layer header included on the first packet. That means layer 4 header. So in the diagram, in the previous, as you can see, the last diagram, the TCP header must be there. That means transport header must be there on the first packet. So if you don't see it, just drop it. So this is the diagram. Everything has to be here, and including the TCP header. So for Cisco, you see the undetermined transport. There's an option to deny anything that doesn't have the transport layer header. Similar thing you have in different vendors. What else? ICMP. Be very careful about ICMP filtering. Of course, in IPv4, ICMP is very well known to facilitate the amplification attack, the ICMP or ping to death, things like that. That's why many network operators actually just block ICMP. There's no harm in terms of network operation for their point of view. But in IPv6, ICMP is very important, not only within your network, but also externally, because the path MTU discovery happens over ICMPv6. The error messages like packet too big, or time exceeded, or destination unreachable, things like that. Within your network, within your LAN, the neighbor discovery, like the router solicitation, router advertisement, neighbor solicitation, neighbor advertisement, all these packets actually use ICMPv6. So you cannot drop everything like you did in IPv4. So here the recommendation is two types of recommendation, and basically reasonable as well. The first one is saying that you permit error messages, which includes the path MTU discovery as well, and also permit the ping. Network troubleshooting requires ping to test. So you can just allow them and drop unnecessary ICMP, other unnecessary ICMP codes or packet types. The other recommendation is just allow ICMPv6, but limit the bandwidth, or limit the size. So here is an example for Cisco. We all know Cisco has this class map, and then you can create the service policy where you can bind with the class map. The class is basically the ICMP packet, and then you create a policy map mentioning that this will be your committed information burst, or CIR, and PCP, or whatever parameters you have. So this is basically saying what is the volume of ICMP packet for your device, to your device. So you can just limit that. NDP attacks includes, and I don't have much time, so NDP attacks includes both neighbor discovery and router advertisement. So I will just cover this this topic in the diagram in the next later slides. So let's go here. So let's say this is a duplicate address detection DOS attack. That means, remember the duplicate address detection. If I'm a device that just recently got an address, I need to check whether this address has been used by somebody else, right? Because IPv6 has this address auto configuration feature. That means I can create my own address without talking to anyone. And then if I want to send a packet with that address, I have to make sure that this is not a duplicate address. So whenever I want to do that, let's say I'm saying, hey, anybody with this IP? An attacker saying, yes, I have that IP. Whenever I'm saying that, it's saying that, yes, I have that IP. That means I'll never be able to use an address because every time someone has that address. So that's the problem. And then the neighbor discovery spoofing, that means a man in the middle attack. So I'm saying, who has this address? I need to talk to you because I want to send a packet to you. So the attacker said, yes, I am that address. This is my MAC. You can just send me that packet. And this happens in IPv4 as well. That means it's a man in the middle attack. My packet goes to that attacker. It captures it and do whatever it does, whatever it wants to do. And then I'm thinking that, okay, I'm talking to the right guy, but actually not. Rogue RA, this is basically router advertisement. Remember, router advertisement has very important parameters. So whenever I want to go to the internet, I need a router as my gateway. So let's say I'm looking for a router who has a routing functionality, and then router sends the parameters to me saying you can use these. So this is the router advertisement. So let's say whenever I'm asking something, some attacker saying I am the router, I can send you a router advertisement, and I'm collecting those and I'm creating my own address and I'm sending my packet to that router. Even though I have a legitimate gateway, I could be a victim where that router, before sending me an RA, I have already received an RA from an attacker. That means I'm not going to accept anybody else because I already have an RA. Why I need a second RA from anybody? So I'll just ignore. So that's the problem, right? So we can use NDP Mon or NDP monitoring tool to monitor that. There's an open source project. You can just download and see. So what it does is basically it checks the RA data, whatever information you have, and then it can create kind of a familiarity with who is the legitimate router here to send RA. And if there is something else, like an anomaly, like somebody new sending RA in the network, it's going to create a syslog and can send it to the admins. Or if you have a monitoring tool based on syslog, you can just see an alert, which is nice to have. This is a functionality called RA Guard in your layer 2 device. So when you buy switches, please try to make sure that at least your important switches has this RA Guard feature, because that can actually give you the option to say that this interface goes to my known router and valid router, so I'll always expect RA messages from this interface incoming to my switch. But other devices are just clients, so I'll never expect RA messages coming inbound in these interfaces. So you can just say this is a trust port, these are not trusted. So if you receive any RA, is basically gonna block that interface. So things like that. This is interesting as well. Send and CG I'm not going to cover, because send is secure neighbor discovery. It uses the cryptographic public key, private key, PKI kind of thing to generate cryptographically generated address, and that's not very well supported by many vendors. So it is a good thing, but because cryptography adds process burden to the devices, so that's why cryptography is never popular for a router or a switch. But feel free to read that, and if you want to try and understand this, okay. This is a scenario where you can have fake ICMP array messages to bypass this technique, the array guard. So for example, I have an IPv6 header that points to a next header. That means my switch will not see a fake array here, so it might not be able to detect it. But actually, array guard enabled switches has other parameters to detect that. So that's not very easy to do that, but still it's better to keep an eye as well. Bogons. Somebody asked whether IPv6 has bogon as well. So bogon, what is bogon actually? Bogon means unexpected routes in the global routing table. Anything that shouldn't be there, if it is there, that's a bogon. Okay. So in IPv6, there are a lot of different reserved IPv6 addresses. And as you can see here on the right side, these are the reason of why it is reserved. So for example, the first one is Teredo subnet. Most of them are basically tunneling subnets. And this is a documentation prefix, very popular. You see 2001 DB8. This is a documentation. These are reserved, and that is not allocated to any network operator. So these should not be in the global routing table. Global routing table should only have public IPv6 and IPv4 addresses. So by public IPv6, it's called the Global Unique Address, or GUA. And these are not assigned to anybody. That's why they're all bogon. So we should not accept them. We should accept the global unicast address, which starts from 2 and 3. So 2000 and 3000, okay? Rest of the prefixes shouldn't be. Bogon, how it was, how can you do team Cambrys peering, and how can you take bogon fits and things like that. I'm not going to cover because of time limitation. It's the same for IPv4. So just take a look at it. If you have more questions, please just reach out to us. We'll cover that at a different time. This is an example of how you peer with Team Camry. If you have heard about Team Camry, they're a community who provide like free, bogon filtering feed, if you want to, and then very popular. Many network operators, they use it. Source address filtering or source spoofing defense. That's called Best Current Practice 38, BCP 38, which basically says that do not allow any source addresses that is not your or your customer addresses to go out your network, right? So that's like source spoofing defense. If an attacker compromise a PC, change the source IP and send a packet, you should inspect the source IP, and if it is not your IP or your customer's IP, just drop it. That's BCP 38. Similar concept for URPF, or unicast reverse path forwarding. And that basically says that whenever you receive a packet, usually this is configured on the first hop or the gateway of the LAN. So let's say I have a IP configured on my router's interface. That means that interface will have neighbors on the other side with the same subnet, because I configured that IP. That means this subnet is actually reachable via this interface. There should not be any other subnet in this network, because I'm the first gateway interface. There's no one on the other side. So something like this. So in those cases, what you can do is you can configure URPF, and in Cisco, the URPF, and Juniper and many other vendors like MikroTik, Huawei, everybody has this feature. So in the interface, you can just configure this, and you can say that reachable via either any or RX. RX is the better because it's more strict. But this is service affecting command if you cannot put it properly. So make sure that you understand how it works. So let's say I'm sending a packet. My source IP is not from the same subnet of this incoming interface. So the router is going to drop it because it doesn't have any other subnet on that interface. So it doesn't expect somebody from other group sending packet through this LAN, right? It shouldn't be in realistically. So it's just going to drop it. And for the lose mode, the router is not going to strictly check the interface. It will look at the routing table whether there is any path to reach that destination. If it is, then just allow. So this is not very good. If you want to use strict mode and use it on the first hop. Use it on the first hop gateway. What else? Other things remains the same. The virus protections, the firewall configurations, and all other security common sense should be whatever you have for IPv4 should be for IPv6. Okay. Yeah, that's basically it. I'm sorry I took about 9 minutes or 10 minutes extra time. I'm sorry for that. I'm really sorry for that. There are some questions. What are the ICMPv6 packet types which can be denied? You can just permit error messages and ping messages. If you have multicast enabled, you can also enable the multicast listener addresses as well. This slide has those, so just allow them, rest of them can be denied. But my advice personally, based on my experience in my previous works, I would say keep ICMPv6 open, rate limit the volume. That's I think a more intelligent approach. It was really, oh, sorry, Dilip, thank you so much for your kind words. Thank you. Thanks so much. Please participate in the survey. We have I think more than 200 people here. I would expect, please, all of you, please give us your feedback. The training is for you. The feedback is for us. So please do that, and it doesn't take more than 2-3 minutes. It's a very small survey. It's not really very customer, like a very long survey. We don't collect many information. We just collect feedback from you to improve ourselves. Please give your honest feedback. Makito, can you please post the feedback link? Oh, thanks, Makito already posted. Please, everybody, please, and request from us. And thank you so much. We hope to see you in our future events. We have online tutorials open for everyone. Just feel free to join. Just keep an eye on our Academy page for the schedule. We'd like to thank our sincere gratitude to National Internet Exchange of India, NIXI, for organizing and giving us the opportunity to talk about IPv6 in front of the bigger audience from India. And I think there might be some other parts of the region as well. Thank you so much for that. Makito, do you want to say anything before we finish?
Yeah, thank you very much everyone for your participation, and thanks for the host for arranging this training.
Do we need a group photo?
It would be nice to have. And I'll mention, please fill up the survey for us. It is very important for us to know what you think about the training for further improvement.
Hi, Chimi here from APNIC. Maybe Chandra, if you could maybe provide some information for your members where they can get the video link. I think I can see there are a couple of them who is seeking some video, the recording you're doing on the session. That would be great. I can also pick it up.
Ask with our management, and then if you need, we will share with you. And also we will upload it at NIXI training, NIXI Academy, training.nixi.in.
Thank you.
And thank you, Abdul and Makito, for your wonderful session. And thank you to all APNIC team. Thank you to participants for attending IPv6 deployment training. Your presence and engagement help to make it a success. We hope that you enjoy the session and found it valuable. Kindly share your valuable feedback, and share link already shared by Makito.
Thank you, everyone.
Thank you.
Thanks,
Bye.
everyone.
Bye-bye.
Have a nice evening. Bye-bye.
Bye-bye.